Hey, how's it going? Welcome, Twitch viewers. Good to be here. So, I tried out a few more little things with OBS today, made a couple of little tweaks as far as like the camera and everything goes. So, let me know if anything seems off or odd, but otherwise, yeah, I'm excited to be with you all today. I realized I had taken this day off a while ago for some kind of plans I had this weekend. I actually totally forget what it was, and I was like, well, I can work in the morning and maybe take a half day and try a weekday stream, so it sounds kind of fun, right? And I kind of like this 1 p.m. Eastern time slot. This is cool because I'm able to catch folks who are in Europe. I see we've got some folks from Europe here. Hello, thank you for joining us, as well as people in the U.S. as well, so that's pretty cool. Yeah, so we already got a little bit of stuff going in the Twitch chat here. Public Grafana URL for metrics. Not yet, but yeah, check this out. So I'm actually running this on my local machine now. So curl, what was the port? Was it 9407? I think I just tweeted it. Let me look on Twitter really quick. Oh, for some reason, one of the fans of my server is like grinding a little bit. That's annoying. I wonder if I can like weigh it down. I don't know. I guess as long as you all can't hear it, I'm not too worried. But what was the port for that? Yeah, 9407. So 9407 metrics, and then let's just grep for OBS. Yes, check this out. So we've actually got Prometheus metrics coming from OBS now. I found this project actually. I will drop the link in chat, and I can pull it up really quick too. But just before the stream. So essentially, this project compiles as a C shared mode binary like plugin for. So like a C program is able to link to a Go program essentially. This is actually something I've never done before myself, but it's a thing you can totally do. So let's pull that up in the browser if I can remember my keyboard shortcut. There we go. Okay. Yeah, so check this out. This is pretty cool, right? So the basic idea is you pull the Git, you do the Git submodule initialization, which I think is pulling in like a copy of like the OBS source tree or something for linking. You copy libobs out. You do this go build dash build mode C shared. So we're creating a C shared object that's this SO file. And I copied that into my OBS plugins folder and started OBS, and suddenly there's an HTTP server running that's giving me metrics, which is pretty cool. You know, that's definitely a pretty wild sort of thing, but it's exciting. So we'll see how that goes, and then hopefully we'll have some cool graphs for after the stream. This time around, I don't have like a dashboard prepared or anything yet because Prometheus is just grabbing the metrics right now, but I will see if I can get something public. That'd be pretty fun, right? So there we go. Cool. Anyway, so let's get back to OBS is pretty cool in general. Yeah, totally. I am very impressed with the flexibility this program provides. Like it's pretty unbelievable. I mean, I'm totally new to it. I'm totally new to this sort of thing, but OBS seems like an extraordinarily powerful tool, which is awesome. So, and I'm just pretty new. I thought we were lacking Windows support for plugins. I'm actually running on Linux, so I am on Ubuntu 2004. So I think there were instructions for Mac on that README as well, but I run all Linux on my machines, so I can't help with Windows stuff, unfortunately. Let's see here. Cool. Checking Slack and stuff, making sure people can hear me and everything. Okay, we're good. So let's get started. So kind of what I wanted to talk about today is, I guess, just in case anybody's here watching for the first time, I want to talk about kind of what we're working on. So I have a... Hey, what's up, Brandon? Thank you so much for sharing it out on the A2 Gophers. The Ann Arbor Gophers group here in Michigan is supporting my stream today by sharing out the word. So thank you, Brandon, for that. I appreciate it. So today, the project we were working on, I call CoreRAD. So Core, R-A-D, whatever, essentially is inspired by the Core DNS projects as well as Core DHCP. Let's see here. I'm going to close that window because it's moving around. Good. Anyway. So this project is kind of my take on what an extensible IPv6 router advertisement daemon would look like. So the basic idea being that there is an old school daemon called RADVD for router advertiser daemon, and it works just fine. The goal of the project is to give your IPv6 speaking machines a default route, as well as possibly assign IP addresses and other parameters. And I used that for years, and honestly, it worked just fine. But similar to the reason that MICG was inspired by... can you quickly outline your use cases? RADVD was always enough for me. Yeah, exactly. So for me, I was inspired by kind of the same way that MICG was. I wanted the ability to have Prometheus metrics, be able to gain more insight into my network. I thought it would be kind of fun to just... kind of like try something on my own. I had already written an NDP package for Go. I figured this could be a fun project, and I kind of have some future use cases as well. So at the moment, I'll bring up the config file. So the default Toml configuration file over here has all of the different options, but really you only need a very minimal configuration. But we support things like attaching prefixes. You can attach routes to your neighbor advertisement or your router advertisements, RDNSS, so recursive DNS servers. That one's kind of confusing. And then DNSSL, which is DNS search lists. So something I think would be kind of cool with this project is if you wanted to have, for example, a variety of routers and have them controlled through like some kind of coordination server, we can have something like interfaces gRPC, and then address equals, controller 9999, something like that. And essentially what I think we could probably do with this project is come up with some pretty interesting use cases for perhaps coordinating like a large fleet of these things. So for example, if you had like a larger network or multiple networks you wanted to manage at the same time through some sort of API, I think that could be pretty fun. I haven't bothered to do that yet because I'm running this on my home network with 4 VLANs and a pretty static configuration. But yeah, it just kind of seemed like it would be a fun project for me, and I really wanted the Prometheus metrics. So for example, if I curl into this, so my router lives here, 9430. You will see that this is where it's running. I'm running v023 beta, which is the last tagged version. We've made a few git commits since then, and we'll be going over some of the stuff I've worked on recently today, and possibly tagging a new release at the end of this stream. I guess I'm not exactly sure yet. But if I go here and I want to look at, for example, the metrics output, you can see we've got a bunch of different output here for things that CoreRAD is doing on my network. So it reports on the state of the interfaces, such as whether or not they are advertising, whether or not you have IPv6 forwarding enabled on the interface, because that will actually impact your router advertisements. Things such as the number of router solicitations received. So when devices come onto your network, they want to find out where their default route is, they issue a router solicitation. We can see these and issue a router advertisement in response, and we also issue these in multicast on a regular interval as well. And something that's actually pretty cool about this that I think is kind of a really neat feature is we now have the ability to detect router advertisements from other routers that disagree with our own. And if we see those, we will actually produce a Prometheus metric, which could then be used for alerting. So if you have two routers that are on the same subnet, but they're providing misleading information, that will eventually confuse your IPv6 speaking clients. So as a result, you want to be able to alert on those sort of conditions. And CoreRAD can actually do that and expose a metric about that. So I think that's a pretty cool feature. And that's kind of the thing I want to do, is give you like a nice holistic view of the kind of like health of your IPv6 network using anything that the neighbor discovery protocol can do. So now that we've got this running, let's just show what it actually does, right? So if I look at the IP-A, let's see here, address show dev emp4so, I believe is my primary. Yeah, so you'll see here, I have a couple of different IPv6 addresses assigned. The last one is the IPv6 link local address, which is generated by default for all IPv6 speaking interfaces. This is scoped exactly to that link and not, it's not routable on the internet or anything. And then I actually have a couple of different prefixes here. So I have my global unicast address prefix, which is assigned to me by charter, delegated via DHCP v6 prefix delegation. And we also have a unique, is it unique local? Yeah, I think it is. Unique local address prefix as well, which you can kind of think of like your internal IPv4 addresses. I actually use this for running internal only services because Charter will occasionally change my /56 prefix and I have to renumber things, which is a pain. So I use this for things like internal DNS only. Today I learned about DNS search list. We'll add that. Yeah, exactly. Do it. It's awesome. I use that as a, for example, the reason that I was able to curl just like my router's name directly is because of that. So if I look at, is it added directly to etcresolve.conf? Yeah, so the search list you can see is added there. That's actually added by the DNS search list option, which is pretty cool. So the way that I actually get there, one more quick little intro thing, we'll dive into the code. So I have this little tool I call NDP that can be used for manipulating neighbor discovery traffic. It turns out there actually is a tool built in called, really quick. Oh, which cat version are you using? Yeah, I'm using a tool called BAT. I will link it in the chat again. I think it's by SharkDP on GitHub. It is pretty nice because you're able to do things like colorized output, like you can cat like a file and it will give you syntax highlighting, which is pretty handy actually. So I'll drop that in the chat really quick. So SharkDP/BAT. Yeah, so if I run this command here, if I run ndp rs, I can issue a router solicitation on my default interface. And you'll see that in response to that solicitation, we receive an advertisement. And this is being powered by CoreRAD, although on other networks, it could be powered by something like RADVD. So you'll see I'm advertising a couple of different prefixes, my unicast local or unique local prefix, as well as my global unicast prefix. recursive DNS servers, the DNS search list, as well as the source link layer address of the router. So this is essentially what it's doing. This is how IPv6 networks work. This is how you find your default route, and also how you are able to do things like stateless address auto-configuration. So I actually do run DHCPv6 at home, but only in a very limited capacity. So you'll notice here we have this flags field. I think this will highlight on the stream as well. This flags other indicates that there is other configuration available on the network using a DHCPv6 server. So clients are able to see this. They can send a DHCPv6 information request and get things like the boot file URL for IPv6 PXE. But I actually assign addresses completely using stateless address auto-configuration, or SLAC, using these prefix information options here with these flags. The flag that matters here is autonomous address auto-configuration. So, cool. So that is kind of what the project does. And today we're going to talk about some of the improvements that I've made over the past few days. So when I did a couple of Twitch streams last weekend, I kind of tore apart the metrics interface as well as the kind of the system interface, like gathering state from the kernel itself. And I wasn't really happy with the way either of those came out. So I took some time to clean them up, and I'm pretty happy with how it's come out. So let's talk about that. So let's start with the metrics stuff. So I guess to be clear here, I work on the Prometheus team, but the stuff that my opinions here are not the opinions of the Prometheus team at all. I just had kind of some frustrations with being able to test the metrics output of Prometheus in a simple way. So I created this metrics wrapper package that I'm going to discuss today. Chances are pretty good other things exist like it, but I actually stole this idea from when I was at DigitalOcean. We had something very similar internally. So I like this package, I like this approach, and we'll talk about that. Do you have any Kanban tool or to-do list for all open source projects? So I use just GitHub issues, really. As far as like what I'm working on next, I don't think I really have like a central issue tracker. I think I tried something like that at one point, but I wasn't really sure. I had a hard time like getting good use out of it. So what I tend to do is just kind of switch from project to project, but I'm pretty good at opening GitHub issues about things that I'm going to be working on. Currently set the DNS search domain via the DHCP reply. Now a client asks for it. Certainly good to have in v6 as well for clients that are v6 only. Yeah, exactly. So this is the equivalent of the v4 DHCP option. The same thing exists in v6, and I believe RADVD has supported it for quite a while as well, which is pretty cool. So let's close the terminal really quick, or at least go full screen in VS Code. So this is kind of my take on a metrics package so far. So I've got a couple of different types in here. We have this metrics interface, and this is the type that can produce metrics functions. So the counter type and the gauge type here are both functions as well. The counter can only ever count up by 1, so it accepts no value. It accepts a variadic series of labels, and the gauge type accepts whatever value you put into it, because gauges can be set, they're used for things like temperatures. So if the temperature changes, it doesn't necessarily always go up like a counter would. So that's what the gauge type does. So kind of where I'm going with this is I want the ability to test my metrics output, but also export things to Prometheus or possibly other sources, or just discard metrics altogether. So I created a couple of little wrappers here. So first we have this, nope, don't want that. We have this prom type. This implements the metrics interface for Prometheus metrics. So you construct it using this new Prometheus constructor. You pass in the Prometheus registry. And then what I do here is I produce these functions using counter and gauge that will actually register values into a Prometheus counter vec or gauge vec using the specified metric name, help string, and then label names. And then when I go to apply labels to this, you actually call the function, pass the list of labels, and then pass the value in the case of a gauge. So the way this works in practice, if I open up the tests here, let's see. I think I need to scroll down. I think I factored these out. Right, so the way you actually use these, so each of these functions accept a metrics interface, and what we do here is we're creating a couple of counters. So in this case, foo total, which is some counter that has 2 labels that are address and interface, and then bar total, which is just another counter which has no labels. Once I actually have these functions, I invoke them, and in the case of counters, that will always increment the value by 1. So basically what we do here is we do a couple of little common routines, and then the tests above can actually verify the output. And for gauges, you have the extra parameter, which is the float64 value. So I'm specifying here things like, the temperature in degrees Celsius or something like that, or the number of bytes, which actually should probably not be a gauge. So this is probably incorrect. Let's fix it, right? So bytes would probably going to be a counter on like an interface. So what is something that would go up and down? Perhaps it's something like bit rate, but I guess it's probably fine. Like something like a bit rate would be acceptable, like OBS would export. Is there any extensions you can recommend for VS Code? I am using not that many, I think. I'm using the Go extension. I think I have a couple of different things. Let's see really quick. Oh, that's not it. Okay, so I'm using a few more things than I thought. So I've done a little bit of work with Rust. So I have like the crates extension enabled and the Rust language server extension. I've got the remote SSH extensions, which I haven't used in a while, but those are pretty cool. So you can actually log into you can actually essentially run VS Code using folders on a remote server. So occasionally, if I want to log into my much more powerful desktop from my laptop, I can do that. And then I also have just a couple of different things like Toml highlighting, Jinja highlighting. Nothing super special, I guess. But the Go extension for sure. You definitely want that, and you want to use Go Please, which is the language server. That's really great too. So back to this. So we have a Prometheus implementation here. We have things like a discard implementation, which given inputs will do absolutely nothing at all. Yeah, no problem. The discard implementation does absolutely nothing. So that, for example, if you don't care about metrics, they'll just be a black hole. That's fine. And we also have this in-memory implementation, which is mostly useful for tests as well. So if I go up here, let's see. So this test memory kind of shows what you do with these metrics interfaces. So given some function that applies to a metrics interface, such as that test counters or test gauges below, I would expect outputs that look something like this. So we have a couple of different time series here. We have foo total and bar total. They have a name and a help string. And then there's a list of samples, possibly partitioned by additional labels. So for example, we have the IPv4 localhost address on ETH0, a v6 global address on ETH1, and then the IPv6 localhost address also on ETH0. These all have a value of 1. So I created this small metrics abstraction, again, as inspired by something we had in DigitalOcean. I thought it was pretty useful, and it also makes it much easier to write tests. Because as a result, we can have like this memory type and use this in tests. So I think what I kind of wanted to do today is get into that a little bit, start adding a couple of metrics where we left off, I believe, in the first stream, as far as like individual router advertisements, and then also write tests for those. So we'll talk about the low-level system stuff later too, but for now let's work on the metrics. Let's see here. So I want to look at the advertiser because this is where most of the metrics are. Actually, I can show you how this is used in practice. So this metrics structure I pass around has all the different metrics exposed by an individual advertiser. Actually, no, that's not true. So the info and the time are per server because they expose the current build information for CoreRAD as a whole, and all these other metrics are partitioned by the interface that is serving them. So for example, in my house, I am running 4 different VLANs, so each of these would be partitioned by the individual VLAN as well. So you create the metrics using the constructors again. You pass in this metrics interface, which is probably Prometheus, but if you pass nothing, it's going to discard metrics using this discard type. We create our gauges and counters. It's worth noting Prometheus supports 2 additional data types, which are histograms and summaries. So those are things I'm going to want to add, but they are a lot more nuanced. So that's something I will probably work on off stream and see what I can come up with. But as far as like counters and gauges go, it's pretty simple. So we initialize a whole variety of metrics here. We set a couple of metrics which are constant for the whole lifetime of the program, such as the build version. We want to know if we're either on like a Git build or a beta version or something like that, as well as the timestamp of when the service was built. Those are both applied by the Go linker. I use those so that way I can tell which release, for example, a user was running. So if we look at the advertiser type now, hello. So if we look at the advertiser type now, we actually use these metrics in a lot of different places. So we want to do things like looking for example, I can talk about what I talked about earlier, the verification of other router advertisements. So when we receive a router advertisement from a different host, we build our own router advertisement using our own configuration, and then we compare the two and verify that fields that would be interpreted by clients as a flapping configuration are consistent. If they are not, we have a hook we can fire here, which is useful for tests, but also we increment this inconsistencies total metric. So we could actually potentially test for that, which would be great. Hello, great to see some Go code. Yes, I love Go. I love Go, I love networking. You're in the right place if you like Go in this stream. So I actually have a test here. This would probably be a good place to start. I have a test that actually sets up a synthetic router advertisement and passes... It will actually set up a synthetic advertiser, and then a client will create a router advertisement. It will reflect it back, pass it back to the advertiser, and then note the configuration differences. So let's look at that test, and then we can go ahead and work on testing that metric. How can I learn more about networking? You know, it's interesting because I think that I don't really have any super definitive books about the topic as like a whole. So there is an IPv6 book I like. Let me see if I can pull that up again. I got into networking, I think, in probably, well, I guess realistically, like my second year of school. The first time I did BSD sockets in C, I thought that was a lot more interesting than your typical, printing something to the screen console application, right? So that kind of really intrigued me, and ever since then, I've been kind of interested in the idea of networks and networking. And I think in 2014, I really just started kind of digging in, learning, what is an Ethernet frame? What is IPv4? What is IPv6? There are quite a few, different facets to the field, honestly. So as far as like a definitive reference, I don't think I really have one because I kind of learned organically just a little bit as I needed to. But I can share an IPv6 book I like. So there's a book called IPv6 Fundamentals. I believe it is mostly geared towards like Cisco equipment, but you don't actually need to understand Cisco gear at all. It just gives you tutorials of like how to do things like setting up DHCPv6 or NDP on Cisco. But I actually like this book. I will drop it in the chat. I thought this was pretty good. It's on Kindle and everything as well, but this taught me a lot about V6 and kind of like inspired my interest in things like the neighbor discovery protocol and ultimately this project. Yeah, of course. If other people have suggestions, please do drop them in the chat. I suspect there are folks who have books that they really like. I know there are some books out there about like TCP IP as a whole, but I've never read anything like that. Did some sockets in distributed systems once in college and I loved it, but I don't even know where to start again. Yeah, exactly. I guess for me, curiosity has always driven me, right? So I will find a problem or something I'm curious about and just kind of start poking at it. Ultimately, that's what led to me doing things like my raw package, which is actually Linux packet sockets, or VSOC, or the netlink package, or neighbor discovery. I've got lots of different network protocols out there, mostly because I just found them interesting and wanted to see what would happen if I did my own implementation and then used it to talk to another computer. So we have a test somewhere that is going to verify the inconsistent. Yes. So test advertiser verify arrays. So we are going to use this test, I think, to begin testing our metrics implementation as well. So essentially what happens here, these tests are unfortunately not for the faint of heart, but we have two different types of tests in this program. We have a simulated test, which basically what it does, agreed, implementing a client for a simple protocol teaches a lot. Yeah, totally. So what's a good protocol? Honestly, TFTP is pretty fun because TFTP is a small UDP protocol with just like a little simple like handshake and sequence numbers and things like that. So I thought TFTP was a pretty fun project. IRC, yeah, IRC would be, I feel like IRC would be okay, but I guess I've never looked at the protocol itself. DNS is definitely not for the faint of heart, perhaps, but I am super thankful I have McG's package, so I don't have to, write DNS stuff myself. MTP, never tried it. All right, let me check my GitHub really quick, and let's see if there's another protocol I could recommend, but I think TFTP definitely comes to mind. I've done so much different stuff. When you get into some things like ARP and Ethernet frames, like you have to learn about packet sockets, which is also useful, but perhaps a little less approachable. You could do ATA over Ethernet. I did that once. That was an experience. Yeah, I think I'm going to stick with TFTP. I think it's a fun little protocol. You can do a lot with it. I think it's definitely a good place to start as far as like UDP-based protocols. HTTP 1.0 is fun. Yeah, I bet, honestly. I mean, HTTP has become a much more complicated beast today. But anyway, so in our tests here, we have two different types of test, essentially. We have a simulated test where what we do is we set up a UDP connection pair and pass neighbor discovery messages between the two because it's much easier to do quick tests that way. And finally, we have a real test, which we actually set up a VETH pair. So we set up two virtual Linux interfaces, and we bind the advertiser to one of them using an ICMPv6 socket. We bind a client to the other one using the other side of the VETH pair, also using ICMPv6, and then we pass real neighbor discovery traffic between the two. So both of these are pretty useful as far as verifying the functionality of the code, but the simulated ones are a lot faster and they don't require root permissions, which is great. I guess both fall into the category of can do it interactively via telnet. Yeah, like HTTP. It makes them easy to debug, compare, and visualize. Yeah, it is definitely valuable to telnet into an HTTP server and try your hand at like writing a raw request just to see what happens. I think definitely HTTP 1.0 would be a super good idea for TCP protocols. So within this test, essentially what we're doing here is we set up an advertiser that's running in the background and we pass in this client context that has all kinds of like local variables. So the client context provides this client type, which is going to be pointed at the server or the advertiser. We read the router advertisement from the advertiser. We do a type assertion because it's an interface type. And what we're going to do here actually, well, so first we make sure the test doesn't crash, or the test will crash if it takes too long. We modify the router advertisement slightly by flipping the manage flag to true, and then we send it to back to the advertiser multiple times. So what we would expect here is that the advertiser would see that and fire this hook above this inconsistent array, put a message in the channel, and then we read that from the channel and verify that it's the router advertisement that we would expect, and that the client sent us a router advertisement with a different configuration. So there's a fair amount going on here, but it actually works pretty well. So if I just click run, this will do the simulated version right within VS Code, and it's pretty quick too. So let's get the terminal back open because we're going to want to see more output. So internal -v, we want to run just the one test. And actually, let's do my wrapper too. So I have this little wrapper called go watch, which essentially is just watching files in the file system for changes. And then every time it does that, it'll run in like a go test command. So we'll do -v -run verify arrays. Yep, there we go. So you'll see here in the simulated test, we have this test0 interface. And it actually logs that it detects an inconsistency in the router advertisement from a router with IP localhost. And we also have the real version, but that's being skipped right now because it actually has to create a VETH pair, and we can't do that without root permissions. So actually, let's skip that one and just go to the simulated version because it'll be tidier this way. More time. Cool. So what we need to do now is essentially figure out how to get metrics out of this test, right? So I think probably the easiest way to do, well, we pass this within the client context type, but I think the problem with that is that the metrics could be modified on the fly while we are using them. But actually, I think I solved that problem because I'm mandating that all of my metrics interface implementations have to be concurrency safe, and I can actually use my in-memory type to gather that metric. So what I will do now is, let's go to where the client context is defined. No, we need to go back down here, and we're going to set up a memory metrics node, actually. So new metrics, but we don't want to pass the raw metrics type. I think we want the output, right? So let's start with this. Instead of discarding the metrics, we're going to produce them but put them in memory. So metrics.new memory. This continues to work just as we expect because it also implements the metrics interface. So we're passing the wrapped metrics structure, but that is not quite what we want, right? And I think I'm running these. Are these in the underscore? They're not. Okay, so I can access internal fields because I'm not in the underscore test package. I just wanted to verify that really quick. Where was I? New memory. There we go. So we actually need to do this for the real tests as well. We will get to those a little later. I'll leave a comment to make same changes in the non-simulated tests. So we have this memory type, we have this metrics type, which is all of our gauges and counters. This is being passed into the advertiser, so the advertiser will populate it, and we're passing it into the client context as well. So we should be able to access that data, but I don't think we expose that through the exported interface. We would need to actually do a type assertion. This is going to be kind of strange, but since we're within the context of our own package, we can do that. So I know in this particular case that oh, I'm looking at the wrong package, sorry. I know that with my metrics type, the metrics node that's being passed in, so this... Oh, we don't store it, do we? I guess we could add it. There's nothing stopping us. Alternatively, we could add a method to this that actually exports all of the data. I think that might be kind of useful as well, but then the problem is... I think that actually seems okay. That doesn't seem like the worst thing to me, at least. So what we'll do here is we will add it so that if the metrics store in here has the ability to output its metrics to in like the series format. So for example, what the memory does, let's pull this back up full screen. We are going to add a method that does a type assertion and looks for a method that looks something like this. So it produces a map of string to metric series. So series produces a set of output time series from the metrics, assuming the metrics were initialized with a compatible metrics interface. If not, series will return Boolean false, or maybe like nil false, right? So I think what we'd actually want here is we want to return this map. So a map that is a string of metrics series, and then a Boolean, which will indicate if the type assertion succeeded. Because we don't want this program to crash, and in the tests, we can just go ahead and assert on that, and it'll be fine. So let's see. The metrics type is going to be our receiver here, and the method is going to be called series. So this will actually dump a copy of all the time series, and because the metrics interface has to be concurrency safe, I don't have to worry about any kind of locking. So I can just invoke this series method directly. So I guess what we could do here is create like a small inline interface, series interface. And then do a type assertion on that. So series metrics, sure, SM. M dot, we need to store the metrics interface as well. The underlying metrics storage. M metrics interface. Yay, metrics. Hey, good to see you here. Yes, yay, metrics. So as mentioned earlier, because I'm not sure when you got here, this is my opinionated take on a metrics package. It wraps the Prometheus stuff. I wanted something that was a little more testable, so I wrote a little wrapper. So forgive me, this is not a ding on Prometheus at all. I love it, but I think the client has a tendency to be a little overcomplicated at times, but we'll see. I might open source this individually. I guess we'll find out. So let's pass this up top so I don't forget about it. MM. So back to our type assertion. We want to check if the M field is a series, and if it is not... Actually, I guess we could just return this directly, right? No, we can't. So return nil false. Type does not support series output. And then if it does, series true. So now we have a new function we can use and go ahead and pull the time series out of this. So if I look over here now, oh, check signal is a similar wrapper I started for my stuff. I want to combine it with tracing and logging. Interesting. Okay. I will put that on the to-do list. Thank you. Let me bookmark that really quick. Yeah, this is something I took from this is an idea I took from something we had at DigitalOcean that I miss a lot, an internal metrics wrapper, which was pretty handy. So this client context is passed into every one of these test functions, and it has this metrics type associated with it. So now we can actually call the series function directly and get a hold of the time series in a concurrency safe way from within the context of each test, which is pretty cool. So I think what we need to do now actually is just plumb this into the other type as well. So new metrics, oops. Metrics, new memory. So now this this metrics node is being plumbed into both types. That's good. So we go back to our verify arrays. And we should be able to see within the context of this test that the metrics were populated as expected. So if I log print line, this is going to produce probably a lot of output, but we're going to see what happens here. What was it? So the client context now has the metrics node associated, and we can call the series method, which will return a map and a boolean that indicated if it's succeeded or not. So SM okay. If not okay, fatal metrics node does not support series output %t, because %t will give us the underlying type, which is pretty handy. cctx mm. And this is going to print a map to the screen, which will not be super useful. Is there? I could use like go spew, I guess. That would be probably more useful right now. So spew dump sm series. Oh no, sm is already the map. So this is... Oh, I'm missing a type. No, I'm not. No, I'm not. Okay, sorry. I got really confused for a sec. So this is actually the series. There needs to be no type assertion because the code is doing that for me. So this is the list of series. So if I call this, and now we can go back over to the terminal. Undefined spew. I'm pretty sure I had that in my... we can go without. We can just log print line. We're going to fix this pretty quick anyway. So clear and go watch. And hey, there we go. So what you'll see here is we're actually outputting a map that gives us all of the different time series that are being produced. And in this particular case, I believe we are initializing this with only the CoreRAD time series. We're not actually putting in the Go metrics or anything. So you'll see here we have kind of this mess of map output. We can actually iterate this and get something a little cleaner. So for series, what are the types here? Series, and then name series. I guess series doesn't really appropriately describe this. This is like a map of metrics. You call it mmap, but that's kind of confusing for Unix people, right? We'll go for TS for time series. Which go watch is that you're using? It is a silly little bash script, bin go watch. So this is actually, I guess I could pretty much copy it into the Twitch chat, right? If I escape it. So it's just a silly little thing. I don't know if it's perfect or not, but oh, that didn't format as I expected, unfortunately. But yeah, the basic idea is run the test once, and then I notify wait on all of the files in that directory, and whenever you see a file change, so if I save something, it'll run it again. And it'll take any arguments I give it as well, things like -v or -run, which is pretty handy. So that's just a silly little thing I wrote because I like having something that gives me real-time feedback. I typically have my... thought it's one of the Go written ones. No, I think there are nicer things. Like I think Caleb Spare has a tool called... is it Reflex? I should probably use something like that, to be honest. But this works okay for me. Typically, I've got this terminal on my larger vertical monitor over here, but so I'm able to see like a lot more output, so it's okay to have stuff like this, but it's a little more cramped right now. Oh, thanks for the link, Dominic. So Reflex is linked in the chat right now. I should set that up, but probably not on stream, right? Cool. So now we have this list of time series, so we can iterate over this. Log print line name TS. Why is that? Oh, I forgot the range, didn't I? So one more time. Okay, so now you can see we're printing each of the individual time series keys, and then we have the different keys associated as well. So the one we actually care about here is the inconsistencies. So you'll actually, can we see it in there? Inconsistencies, yep. So we'll actually see the inconsistencies metric is being set for test 01. Perfect. So now we need to verify that. So filter by the inconsistencies detection metric. So if name not equals, I guess I could hard code this, or I could, I think we're within the scope of the package, so perhaps I can make a constant. I don't know. I don't really want to have constants for each of my metrics names if I'm going to test all of them, but I guess it's probably not the worst idea. I mean, you know, let's just get started. Names of metrics which are referenced here and in tests. So RA inconsistencies. I think that's probably fine. Maybe I should prefix them with like metrics or something. Metric RA inconsistencies. This is fine for now. I don't think I moved a lot of stuff out of this package, so the package level namespace is a little less polluted than it was before, which is good. So now we need to take that string and replace it because, there we go. RA inconsistencies. And RA inconsistencies. Continue. So now we're filtering down to an individual time series. And as you will see, we have just that time series to look at now. So we can actually pull its data points out and then verify that it's set to 1. Yay for rename identifier. Yes, exactly. It's so useful. So the, what is this data structure? I already forgot. Metrics series is a wrong package again. This is what I get for naming files the same thing in different packages, but you know, names like metrics.go are just so good. What is the data type? I forgot. Series, here we go. Samples. So name help samples. We don't really care about the help string. The name is already matched. I just have it on the value for convenience as well. So samples. So we want to look at the samples, which is going to be partitioned by the labels. So eth0, interface equals eth0, I believe, right? Interface equals eth0. I think that's over here actually, or interface equals test0 colon 1. So the value is 1. The label name is going to be interface equals test0. So do we pass the name of the interface? I'm pretty sure we do actually. Now verify that a metric was produced indicating an RA inconsistency detected by this interface. Yeah, check that out. Nightbot commands. I'm such a pro Twitch streamer, right? It's kind of funny. I set it up when I set up Nightbot last weekend, my brother immediately came in and started spamming emotes, and it slapped him with a 10-minute ban. Oh, uptime. I don't have that, do I? I thought that was built into Nightbot, but I guess maybe not. Or it might be trivial to enable it, but I guess I'm not really sure. So we're looking for a time series with this value. This is 300% higher production value than a lot of streamers have been going at it for a year plus. Well, hey, I'm glad to hear that. It's kind of funny. The way my brother describes me is that I never take like a half step into anything. Like I kind of plunge head first. So I had a stream on last Saturday. I had one scene because OBS was giving me crazy problems. And then by Sunday, I had spent 6 hours in like OBS. Like that night, I had like 8 different scenes. So check this out. You ready? So we've got the coding scene. We've got the stream starting with audio so I can talk to you all. We've got audio video with the banner. What's up? Full screen. We've got a nice little password input. That's pretty nice. And then I can also take a break. So pretty cool. Video and audio quality is !2. Hey, good to hear it. I think I cranked the bit rates today. I think I'm pretty much doing as high as Twitch will allow, and then the local recording is much higher. So with any luck, the YouTube videos will look nicer than the Twitch stream, which is good. Keep it. So you're saying you're over-engineering, keep it just on you. I think people are here probably to see the code. But, oh, hey, good to see you. Good. Thanks for stopping by. Quality is very good for me too. I'm glad to hear that. Yeah, I'm on a wired gigabit download, but 50 meg upload connection, so it works, you know. Hey, I've been really good. Just having a good time, you know. I kind of figured last weekend that it was about time to try the streaming thing, and having a good time doing it, so why not? No complaints. So now we have this time series value, which is going to be a float 64 of 1 because an inconsistency was detected. So TS samples, right? So we're looking for a sample with that name, and then the sample is going to be the float 64. So we don't actually need to check for it because we'll get the 0 value otherwise. So what we want is 1, and the got value is TS samples, so unexpected. Unexpected value for interface test 0 inconsistencies. Oh, the type coercion here. So I have to coerce this to a float 64, or I guess I could do the other way, but it probably seems... Actually, can I just do one dot, or is that Rust? Nope, that works. Sweet. Perfect. So now we actually have a test that verifies that given an inconsistent router advertisement sent from a client, we not only receive a notification about it, we actually increment a metric that we can then use with Prometheus to go ahead and alert on this. So this is I think this is pretty cool. Like, this is definitely like a differentiating feature. I'm pretty sure RADVD will like log this to syslog or something, which is great too. Don't get me wrong, if you have like good log processing tools, but I find that the more and more I use metrics and things like tracing, I have less interest in ever using logs, like, again, really, except for very exceptional circumstances. So I'm pretty happy with this. I think this is probably the right metric we want to check here. Maybe we will factor out some sort of helper to do this map iteration and fetching. We'll do that the next time we use it, but I'm sure we're going to need that again pretty soon. But I think this is probably in a good place to commit, actually. So you should use mtail on everything, honestly. Isn't mtail that like Google log exporter something? Maybe it's not Google. I guess I'm not sure. Oh, I guess I can actually get rid of that to-do now, can't I? Right, yeah, I've never tried that. I actually did try, if there's any Grafana folks in here, I did try Loki. I had it running on my server for a while. I took Loki down when I moved over to NixOS, so I need to reinstall it. But I want to get it running on all my machines again because it was pretty cool being able to do things like filter on SSH brute force attempts, because welcome to the IPv4 internet. People scan the space all the time and just constantly try and get into your SSH servers, which is pretty fun, right? So cool. We were able to take the metrics package I wrote, fetch the time series here, pull out an individual metric, verify it's incremented. I'm going to call that a win. Do we want to hard code test 0? I think we can parameterize that with like an sprintf or something like that. For the purposes of these tests, it's never going to change, but I tend to not like hard coding when I have the variable available anyway, right? So expected value for interface inconsistencies. So label := format sprintf. Yes, format, not fumped. Okay, Rob Pike, I don't get it, man. Just format is fine, right? Running Loki 2, you should use the tools for what they are best for. It doesn't replace metrics, just want to make that clear. Yeah, absolutely. I think the thing is like I kind of have an aversion to logging because I've seen lots of really bad logs. So I guess in my mind, things like logging individual requests, a successful request is pretty useless. Like that should be a metric, I think, all the time. I can't think of any use case where like you want to log like an HTTP 200, you know. But for a 500, if you have something like a Go error, that's a lot more useful. Interface equals the name of the client context client interface name. Yes, I believe that's exactly what I want. Oh, shoot, that's going to run all the tests. Oh, nil pointer dereference. Am I not passing? I think I might have gotten the client context out of sync. Client context. Yes, I'm not passing it in the simulated tests, am I? I am not. Config name. So I'm passing it to that dialer context, right? Yeah, router, right. Oh no, I don't want the client's name. I do want the router's name because this would actually be the interface from the router's perspective and not the client's perspective anyway. So let's verify this in the other spot before I move on. But yes, so this metric would apply only to the router's interface. So for example, if I run this on the VETH pair, the interfaces will have different names. So interface equals the router's interface name, not the client's name. Let's go back to this. Okay. And I guess just for good measure, let's go ahead and run this with the other version as well. So in order to get the other version running, I have to pass sudo or have to pass permissions. You might log 200s if your government requires you to. Yeah, maybe. I guess I'm not in that situation with my my hobby project on Twitch, you know. Even then, you can simplify store them. You don't need to store them in Elasticsearch. Yes, very true. Yeah, Elasticsearch is its own thing. So go test -c. So we want to compile a test binary, set the capabilities on it, or we could just sudo. I'm just going to cheat. I mean, CoreRAD test, and then -test.v -test.run. The government logs it with backdoors for you. Yeah, exactly. Hey, what's up, NSA? Thanks for coming to my Twitch stream. Like and subscribe. Twitch.tv/mdlayer, YouTube/some random URL. So if I run this test with sudo, this is actually going to run both of the tests, the simulation as well as the VETH pair. So let's open this up a little wider really quick. You will notice that within the test here, so the simulated test passes just fine. The real test will verify and create interfaces. It will create a VETH pair with 2 random names. It will turn off duplicate address detection because that slows down the interfaces coming up, actually. That it slows down them acquiring their link local addresses. It turns on forwarding because we need that for the router's side configuration in order to influence the router advertisement. We've set both of the links up, and then we actually have a VETH pair that we start the IPv6 sockets on and do a real router advertisement, which is pretty cool. So you'll notice the CoreRAD 8053 is the router side. Detected an inconsistent router advertisement from IP this. So if you look at the IP address, actually that'll be deleted by now, won't it? IPL. Yep. So the interfaces get cleaned up when the tests pass. But you'll notice it actually did detect an inconsistent router advertisement from the other side of the VETH pair, which is pretty cool. Gotta head to a meeting. Thanks. Hey, take care. I'll probably be here for another couple of hours, I imagine. So feel free to stop on by. Cool. So I feel pretty good about this test. We plumbed in the metrics. We added the series method so we can access the data. I suppose we could potentially put this method in tests only. I'm not sure if it'll ever need to be exported elsewhere, but I guess it could be useful. Right. So cool. I think we're in good shape to commit this. Star. Nope. Internal initial metrics test for inconsistent RAs. Router advertisements RAs. Yep. And push. And cool. First commit down on the stream today. Sweet. Back to the browser, or back to VS Code. So I think probably we could potentially do this in more places that might be useful. We could add new metrics. I got to go back to work. Thanks for doing this. I got to do some Prometheus stuff soon, so I'll probably bother you. Hey, feel free. I work on Prometheus. I am not a PromQL expert especially, but there's lots of really cool stuff out there, and I can definitely get you in touch with the right people. So, hey, take care. Oh, actually, I guess on that topic, I should show you all something really quick. So this is extraordinarily cool. I wish I had it pointed at my local Prometheus, but I do not. But, so JuliusPromLens.com. Julius Volt, one of the co-creators of Prometheus, just created this tool called PromLens. This is extremely cool. So let's see here. How do I get an example query in here? I think I had one yesterday. Go routines. Sure. So this tool, what it'll let you do is you point this at your Prometheus server. So I wish I could point it at mine, but I'm running behind traffic basic auth, and I would have to either poke a hole or wait for... Can you explain it to me? Don't look at the UI flow. Yeah, me either yet. But what's super cool about this is it'll actually break down your PromQL queries into individual pieces. So I can not only look at the different metrics here, but I can actually take a complicated query and break it down, and it will give you more information about it. So let me pull a query from one of my dashboards. I'm sure I've got something from Node Exporter that would be good, like the CPU utilization. So if I do something like this, I'll take the instance labels out. Do it. Right, so what this allows you to do is actually take a query, and how is the zoom on this? I could probably make it a little bit bigger. It will actually take a query and you can break it down piece by piece. So this is extremely super cool. What was I doing? Right, so you can apply individual parts of the query. What am I doing? Oh, right, it's only evaluating that part. So if I want to apply the irate itself, you can see this, and you can jump back up to the aggregation by the sum. It will do things like explain to you, let's see here. I was not prepared to give a demo of this, but did I break it? Oh, sums over the values. Okay, so I thought it would break this down more. There are some better queries, but basically this is a super cool tool. So check this out. This is promlens.com. I think this is going to be a total game changer tool for Prometheus use in general. Check this out. Also, Julius is starting a company called Prom Labs. It's going to be very cool. Creating products like this. Adding nice tooling to the Prometheus ecosystem, making Prometheus easier to use. Didn't get you can execute individual parts. Yeah, totally. So if I go to irate here, yep. This is explaining what irate does. We can actually see the graph for that individual part. Needs to be integrated into the Prometheus query UI. That would be cool, but also Julius needs to make a living, so I can certainly understand from both perspectives. Yeah, check that out. This is something I'm definitely going to be using at home whenever I'm able to set that up. So back to the code. Cool. So we got that working. That's pretty cool. We could talk about more metric stuff. We could add some more tests in that area. What else do I want to look at today? Or Grafana needs to add a link to PromLens alongside the link to Prometheus. Yeah, that would be super cool too. So I think the idea is... Oh, our intern worked on a PromQL language server to at least give support while writing queries. Not sure what the integration status is. That would be super nice, actually. Yeah, a PromQL language server would be great because I am pretty horrible at PromQL even to this day. I find myself copying and pasting examples a lot, Let's do a quick look at the coverage and see if there's anything else I want to work on. It's in the Prometheus community org already. Really? Oh, that's super cool. Nice. There's more stuff we could test here as well. I'm curious how much I want to get into the weeds on this today. We could look at the system stuff. I guess we've only been going for like an hour. Metrics nil. Yeah, discard the metrics. That's what we want. Does anybody... Let's discuss the issue about have con execute wait for ec. A lot of people involved are here. Yeah, maybe. Yeah, so if anybody here uses my netlink stuff, go check out the repo right now. There is an issue open where we are debating what to do when... Long story short, if you pass the acknowledgement flag and netlink was going to return a response to you anyway, it will produce a secondary message which can kind of trip up the client a little bit. So we're debating how to handle that. So if you've written any netlink code, please do go check that out. That would be super, super helpful for us to have more opinions and better understand the use cases. So. What I really want to do is do things like simulate receive errors and verify this back off logic, but I'm not sure if I really need to get into that today. There's other things we could check, like the hop limit verification. I feel like I had a test for this. Maybe I do in the non-simulated mode. So if I do, oh shoot, I need to cover profile everything. Go test. Oh boy, a Slack message. What's going on? You are now my favorite streamer. Tuned on to the stream, didn't bother to make a Twitch account, so can't join the discussion. That's funny. I'm happy to be somebody's favorite Twitch streamer, I guess. Oh, shoot. I never updated my title today. That's funny. Anyway. It's essentially the same thing, but what I wanted to do is put the same thing as the banner text. So let's see here. Code, stream, banner. Need to remember to do that. At least my category is still the same thing. New metrics and system packages, more tests, go networking, IPv6. Cool. Stream title updated. For your packages, this is okay. Don't expose the change to the client. Yeah, I don't think any of the higher level packages would expose it, but I wonder if something like the mid-level, the contract packages or route netlink would expose it. I guess I'm not sure. I want to run a full coverage report and get an updated one because I have one here, but it's out of date. So I think what I need to do is go test -cover right? Go test-cover-c sudo test. We want to run all of the tests. We want test.cover profile equals cover.out. That's the name I always use. That will run every test. Oh, I guess I could have got rid of -v. Excuse me. I actually went through and parallelized all these tests the other day too, so everything will run in like a lot faster now, which is great. So 3.3, 6.40 seconds for that test. Yeah, there's one that has to actually like simulate like a timeout essentially. Like it has to wait like 3 seconds because that's the NDP hard-coded parameter. But I think I was actually going to go ahead and parameterize that because it would make the test go a lot faster. So now we have a cover profile in the raw format. So if we do go tool cover, the problem is I'm not sure which browser this is going to show up in. So I want to verify that it's this one, hopefully. So please, oh, shoot, there we go. Nope. Lost it, okay. So hopefully it will show up in that browser. No, it did not. It showed up in my Twitch browser. That's fun, okay. Anyway, we'll pull it up full screen over here. So back to my stream manager. Okay, cool. So this is the current cover profile using the Go tool cover. I could probably figure out a way to pipe this into VS Code because I use the VS Code integrated coverage a lot more often now. But the problem is I need to run it with sudo or both the capabilities it needs, which is capnet raw and capnet admin. And I don't know an easy way to do that in VS Code yet. So now we can actually see which paths are covered, which is good. Multicast only mode or unicast only. Yeah, we need to work on that. Emacs Go mode has built-in support for rendering coverage profiles. Oh, that's cool. Maybe VS Code does too. Like maybe I could open this somehow, but I guess I've never tried. Are you telling me I should use Emacs? Because it's not going to happen. We've actually got pretty good test coverage in general. I feel pretty happy with this. Yes, we do cover this hop limit case in the case of... I think the simulated tests don't cover it because we don't manipulate the IPv6 control message, but the real tests do. So we can potentially add a metric for this as well. Like we want to know if clients are sending us like bogus hop limits or something. That could be useful potentially. Or if clients are sending us bogus NDP messages. Although in this case, we actually have the ICMPv6 filter type set up, so I would be very surprised if something got past that. Maybe we can do a test where we disable the filter and check that metric. I feel like this package is pretty well covered. Ah, right. Okay, I see where we were last stream, or 2 streams ago? Last stream, I think. To do work on during a stream. How perfect. So let's go look at that, actually. I have to drop. Enjoy the rest. Hey, thank you for stopping by. Take care. Build RA. Right. So let's quiet that down for a little bit. So what I want to do over here is see you next time. See you next time. So this is something else that I refactored a little bit last time as well. So we used to have, I guess I could go over the system package now. This would probably be a good time. So essentially we had kind of this weird low-level system abstraction called the con, which was kind of a combination of an ICMPv6 socket for neighbor discovery as well as like fetching the kernel state. So for example, the IPv6 forwarding state. So now I have this new system package where I abstract these things out a little bit better. And also I got rid of all of the retry logic from this package and moved it into system as well. So if I go up to the top, one of the main methods in here, so advertise is kind of our entry point for each Go routine. They will pass in a context, which is used for cancellation, as well as this channel of state changes. So for example, when the link goes down, we'll actually get a state change. So this dialer type, this system dialer, actually creates NDP connections and such, and passes them to you within this function here, which has this dial context. So this will give you a con, which is wrapped in the interface, so we can do things like have NDP or UDP for tests, the interface you are binding to, the address you are bound to, so you can do things like logging, and also this unexported function that cleans up. So what the dialer will do is it will continuously attempt to redial this function here with a new system context every time something fails. So if we get an error that's related to like the socket having invalid argument because the link was taken down, This function will return an error, the dialer will catch it, and it will go into a back off and retry loop. So I took all of the retry logic and put it in this dialer type, which is pretty cool. So the way this works essentially is every time it comes up, we initialize the plugins. So plugins need to know about things like the current addresses on the network interface so they can figure out which prefixes to serve. We send our first link local all nodes multicast router advertisement. And then we begin the advertise function here, which actually does things like initializing the various Go routines, such as the listener, the multicast scheduler, and etc. So let's take a look at the system package. Let's close some other folders here so I don't get confused. So this is something I talked about doing last stream but never actually did. Did I not have a dot comment for this? Really? Wow. I never usually forget those. Okay, let's add a dot comment. First of all, package system. Package system provides a portable interface to low-level system operations. System networking operations? System networking operations. I think that's probably a pretty accurate descriptor. I made the Twitch account as you requested. Does this mean I can tell my teenage daughter I'm an Instagram influencer? Yeah, maybe. But yeah, Twitch is super cool, actually. I mean, I started on Twitch actually as like just viewing games, and I didn't really understand the appeal of like Twitch and Twitch chat until I hopped into like some streams and just was there for some of the very funny moments, you know. But it's a lot of fun, and especially stuff like this, like it gives us the ability to interact. You know, people can ask me questions, I'm able to answer. We can talk about whatever, you know. So I think Twitch chat is pretty fun. So we'll add a dot comment because I'm picky about that sort of thing. Still waiting for the very funny moments here. Oh, you mean like a highlight video or something? That'll be interesting. Internal system. Add doc comment. Yep. So not everybody is a fan of tools like golint, but I'm pretty insistent on keeping my code bases golint clean. Oh, here's one for you, Dominic. So if I run this, hey, no errors. So the other day, actually, when you were not on the stream, unfortunately, I ran static check, and I think there was a problem that I caught before I committed, thankfully. But so this con interface here is actually a wrapper over the NDP cons methods, or the ones we need, such as reading an NDP message, writing an NDP message, and then setting a deadline. So we use the deadline in order to do things like cancellation of the connection, whenever a connection is reading. So if I go back to the advertiser, set read. Whenever a netcon in Go, and this is not a netcon, but the same behavior applies. Whenever a netcon in Go is reading like this, if you want to interrupt it, you can set a deadline in the past. So in this case, I set the read deadline to Unix time with 1 second, and this will immediately interrupt this read. And in this case, I can check for context cancellation and go ahead and stop this reader. So this is a pretty handy little trick as well. I would love to kind of encapsulate this into like a package, like a context-aware networking package, but the problem is that I'm not sure how well it can be generalized. I use this pattern in a few different places, but I would have to think about it some more. It's something I would love for the standard library to support as well, but I think we'd have to hook into the runtime, and I'm not sure those hooks exist today. So moving on, we're back to this con interface. So this abstracts NDP con, but we also have in the tests, we had the UDP version where we actually set up a couple of listening sockets, point them at each other, and then actually marshal and unmarshal neighbor discovery messages. So with that, we're able to do unprivileged tests, which are a lot faster and don't potentially mess with my system state, which is nice. So this package, basically its job is to do things like probe the network interface for its capabilities, like verify it's got a MAC address. This has to be an L2 link for NDP to work because NDP is kind of the IPv6 equivalent of ARP. It needs to have a source and target MAC addresses within the packets. We have to make sure the interface is actually up. Oh yeah, one more thing I wanted to mention. So something like a WireGuard link, for example, does not have a MAC address because WireGuard is natively a layer 3. So WireGuard, you actually transmit IPv4 and IPv6 packets directly and not Ethernet frames. So that's the critical part there. The interface has to be up. It has to have an IPv6 link local address because that's how the communication works for neighbor discovery. And those are the preconditions. So This type's responsibility is wrapping the low-level neighbor discovery operations. We have the dialer. Ooh, excuse me. Oh, water down my throat. We have the dialer type. The dialer's job is to dial out connections and then keep invoking this function repeatedly until it returns an irrecoverable error or the context is canceled. So this is all the retry logic that was once in the advertise function. To be honest, I wish I had done this a lot sooner because that was probably one of my least favorite parts of the code, and it's gotten a lot cleaner now that this is all factored out. And finally, we have this state type. So this was also originally part of the con interface, but the job of a state type is to abstract the low-level system state, like the IPv6 kernel parameters. So in the case of Linux, what we're actually doing here, if we want to get the IPv6 auto configuration or forwarding, we jump to these functions right here. So we're actually reading these from the proc interface in the file system. So proc sysnet IPv6 conf, and then keys such as autoconf or forwarding. We can also enable them manually as long as we have the appropriate permission to do so, which is cap net admin. So cap net raw allows us to open ICMPv6 sockets, and cap net admin allows us to write to these files. So we can do things like disable auto configuration, because when we are serving router advertisements, we want to turn off auto configuration on that interface, or else I believe our own router advertisements can influence us and add more IPs on that interface, which is pretty strange. So that's something we do by default. And we also want to make sure the system is actually forwarding packets, because if it's not, we cannot advertise ourselves as a default router. So something I would like to do at some point as well is get a FreeBSD VM going and implement these for other platforms as well. I guess the last time I looked, though, I'm not a BSD expert at all, but the last time I looked, I'm not sure BSD allows you to do this per interface like Linux. So for example, I think forwarding might be like an entire system parameter versus an individual interface parameter. But we'll have to see, because right now we just assume that if you're running CoreRAD on FreeBSD, you're forwarding packets, but this is not necessarily true. So we need to fix this at some point. But I did do a brief test with a FreeBSD VM on DigitalOcean, and it actually was able to send router advertisements, which is pretty cool. So I would be surprised if anybody was running this on anything but Linux, but it is, I will say, like a secondary goal of the project to, well, Linux is always going to be the first class citizen, but it is a goal of the project to work on all platforms. Like if somebody wants to contribute Windows support, you are more than welcome to. I think in that case, you'd have to go to the XNet packages. The ICMPv6 package or sockets would probably need some work in that area. So now that we have this system abstraction, things are a lot cleaner. We're able to do things like just fetch the state that we need, such as the IPv6 forwarding state. And we can go back to the advertiser and the build RA function. And now we have this factored out in such a way where we fetch the IPv6 forwarding state. We call this router advertisement function on the configuration because the config defines which configuration fields go where and applies plugins, and then also applies things like the router lifetime. And finally, we can return the router advertisement to be sent to clients and also do things like update metrics. So this is where I stopped. I think it was either last stream or 2 streams ago because I wasn't happy with the metrics interface, but now that that's been fixed and we've also decoupled the system state, we're in a lot better place to tackle this. So let's get back to this. Let's add some information metrics to give us info about the different prefixes and such being served by an interface. So if we log this here, what we're going to do really quick is run the development version I've got. So if I, let's see, what's in the configuration file at the moment? We've got a route, don't care. I guess we could just serve a fake prefix instead of having to assign it to the interface. We could do fd00 dead beef dead. So this is in the unicast local or unique local range. This is not typically how you do this. You would want to run like some kind of tool. Like I actually wrote a little tool for this. Ready? Ta-da! So actually, hey, let's use this. So this is a completely unique IPv6/48 that can be used for unique local prefixes. And you can actually allocate, so 16 bits, you can allocate 65,536 different /64s out of this range, which is pretty cool. So we're going to take one. We're just going to use this in our test. That's fine. We want to advertise. I don't think we want to advertise on v1 right now. So what we're going to do is we're going to build the code as it stands today. We're going to run it. Let's see here. CoreRAD. Open. Link not ready. Right. So I also have a couple of shell scripts in this repo that allow me to do things like the development interfaces. These I really should commit these to. I really should commit these. I should add a note for that somewhere. They're get ignored right now, but they're pretty straightforward. Basically, the idea is you set up a VETH pair, point them at each other, enable forwarding on one of them, bring them both up. That's about it. And then with these, I'm actually able to do local development and verify that things like router advertisements actually take effect without messing with the state of my system itself. So let's add a to-do somewhere that I will see it, like the README. There we go. So now that'll bother me in the Git status. I too have a folder full of scripts that should be committed one day. I think everybody does, right? I mean, I'm pretty embarrassed by my bash foo. It's not very good, you know. So yeah. So now we're gonna see this whenever we do a git diff. So that'll get annoying pretty quick, and it will make me hopefully change my mind, right? Okay. So we make, and then we are going to run it. So we need to set capabilities on it as well. Sudo set capnet admin, which we need to apply the auto configuration, and then capnet raw for the IC and IPv6 sockets, plus EP. I can never remember what that's for, but you need it. Not bin command CoreRAD core. Okay. And then run it. We're just going to make a quick little one-liner because it's going to get annoying to type this out otherwise, and I want to run it from the root directory so I can use the makefile. All right, do the password entry thing really quick so I can apply the capabilities, and there we go. But I still forget to create, oh, so this is cool. That can actually show you how this works. So what this will do, CoreRAD assumes nothing about the state of your system when it comes up. It will just keep trying for like 2 minutes or something like that. But if you bring an interface up while it's running, so doing the same thing again, it will attempt to bind to it. It can't do that. It'll retry. And finally, both the interfaces come up just fine. Actually, why did it print that twice? Do I have that listed twice? Or do I have a bug? Maybe. Interesting. So you'll see we're advertising that prefix. Let me start it one more time really quick. Now that the interface is up, it should work fine. No, it just printed once. Okay, maybe there is a bug in the retry logic somewhere, but it's not that big of a deal. It just logs something. So you can actually see that every time we send a router advertisement now, we are printing the prefix we're sending. So what I want to do is I want to put this in the Prometheus metrics so we can actually take a look at this and get a glance at what our server is doing, advertising which prefixes on which subnets, especially because we allow a dynamic configuration. So if I, for example, specify prefix equals : /64, it will actually pick up any prefixes in that interface that have a /64 mask. So this is actually the same behavior as in RA DVD. But in this case, we're doing it explicitly because we just want to test this. So now we have a prefix. We're printing it to the screen. We want to create some metrics. So I think last time around we were going to work on something like an autonomous flag, I think. Yeah, actually, I think I created the metric, but I forgot to actually initialize it and such. So after or before inconsistencies, router advertisement, prefix autonomous is a gauge because it will always have the value of 1. So that way you can do what is effectively a promql join by using multiplication. CoreRAD advertiser, router advertisement, prefix autonomous. How do I indicate booleans beforehand? I think I have more booleans somewhere else. Yeah, indicates whether or not, right? Indicates whether or not the Slack flag is enabled for a given prefix. So this metric is going to be partitioned by, let's see, the prefix is always going to be, we can't serve link local prefixes. Is the prefix always going to be unique per interface? I think I had this. I think I had this question last time too. I think I remember talking about this. But what we want to do is we want to indicate which prefix it is for sure. The value of the Boolean will be in the metrics value, but we also want to make sure that I don't know if this is going to be. Would it be valid to advertise the same prefix on two different interfaces? I guess if you had like a bonded configuration, you would advertise over the bond, right, and not the individual interfaces. So I guess we could leave the. We do want the interface because each advertiser will have different prefix configurations. So I guess this is probably okay for now, but I am not sure to do verify uniqueness of prefixes per interface. Right. So we have two labels. We have the prefix and the interface is being served off of. So now we have that gauge. It will be registered automatically. We need to set this in our code now. So the advertiser has a metrics node field. The metrics node will router advertisement prefix autonomous. Based on the Slack flag, we will advertise this information. So don't I have a bool float? Yes, I do. Sweet. This would be prefix information, autonomous address auto configuration. Yes, right. It's silly. I'm sitting here coding on 4K monitors, and I guess I've got the text up pretty large, but I still believe in the 80 character line limits where possible. Is this 80 or is it 100? It is 80. Because what's cool about this is if I have it at 80, I'm able to have like at least 3 whole things of code side by side. So sometimes you'll get, code bases that have it super long, or like some of these strings can't really be helped, but where possible, I still believe in 80 characters, And then we apply the labels, which is the interface being served off of. So a config name. Was that right? Or I guess we have the interface's name. We have the config interface, so IFI name, as well as the prefix itself, which is PFX string, because we create the prefix up here because right now we are passing around the in the prefix information itself. So in the raw NDP option, it passes the prefix and its CIDR mask as different fields. We want to combine them because from our perspective, they're logically one unit, but it makes it easier for the binary parsers if they're separate. It makes the protocol more efficient. So, okay. So now we are indicating whether or not the prefix, each prefix has the autonomous bit set. So what we can actually do now is we'll create a second prefix with a different name. And we will turn autonomous off, actually, so we can verify the 2 different cases. So now I can run that one-liner again. We're going to do a split because we want to be able to use curl. Okay. Curl-s localhost. This is where CoreRAD is running. Metrics, grep, autonomous. I guarantee nothing else is going to have that in its name. And as you will see, we have 2 time series, interface CRAD v0 prefix. This one's autonomous, this one is not. So perfect. We now have metadata. Should do horizontal monitors, can fit 3x 141 characters. 72 characters to fit on a punch card. Yeah. I've actually never had to use punch cards, thankfully. Horizontal monitors. 3x. Yeah, I do. Well, I have horizontal monitors. I'm coding on a horizontal monitor right now. Maybe my font size is larger than yours. There was a little bit like last year where I was having like lots of like headaches on computers and stuff, so I bumped my font sizes. So I think I might have like, aging eyes already or something. So cool, we have a new metric. We're actually able to verify it. You've never been to the Computer History Museum in Mountain View? No, I have not, actually. That is a place I really want to go. I haven't been to California as a whole in quite a while, but get your own punch card from the IBM 1401. That sounds sweet. I was actually supposed to go to California last month to go on a trip to visit various places like San Francisco, so that actually is a good idea. I'll keep that in mind for future. But we were going to go tour Alcatraz. We were going to go to Santa Rosa and go check out Russian River. So the beer shelf, I guess I can do this really quick. The beer shelf is normally cropped out in like the small view, but over here we have the shelf of beer. I'm definitely a big beer fan. And in Santa Rosa, there is Russian River Brewing, which is super cool. So I would love to go to Russian River eventually. Back to this. Cool. Go today. Oh, wait. Yeah, I'm only a couple thousand miles away. No problem. But I'm sure eventually I'll be back at Fastly's HQ. Okay, so this configuration seems to work for development. We've got the new metric. We can actually verify it as well, which is cool. Right. So we can write a new test to verify this, I suppose. Or we could add more metrics. Now that they're pretty lightweight, easy to create, we could do... Yeah, we want the Slack state for sure. Let me think of what else. So if I pop open a new window, this is all the information that I'll do this again. This is all the information that one of my router advertisements gives me. So what are things here that I could care about? So I think the prefixes are probably the most important. I want to know what the prefixes are, maybe what their flags are. I could check for on link, but I don't... See, I guess I wonder like in what circumstances you would set not on link, maybe. Because on link tunes whether or not the devices can use local neighbor advertisements or whether they should go through the router. So maybe if you don't want devices to talk to each other or force everything to go through the router, potentially if you have like some kind of SDN thing going on. I could expose like the valid lifetime and the preferred lifetime, especially because those could potentially change if I add expiration functionality. Yeah, I'm just trying to think of like what parts of this would be useful to expose, right? I think definitely the prefixes, because prefixes can be dynamic, so that's something we want to expose for sure. So given an interface, you will see, you'll be able to query which prefixes it is advertising, because if I add a new prefix to the interface, well, I can demonstrate this actually. I could log into the router and, okay, so sudo IP adder add, C for 193, a brand new /48. So we will add this to my lab VLAN. IP adder add : 1, right, /64 dev lab 0. Am I missing something? This is probably going to complain. I feel like it shouldn't, but okay, we'll do this one more time. Okay, so now if I use my lab VLAN, you will actually see that FD69 got picked up. So this is what the : /64 does. Every time you add an interface, CoreRAD, when building a router advertisement, will pick it up and begin serving it immediately. So that's the default anyway. You can explicitly set it so that if we want one of these to not be autonomous, we can do that. And as a result of seeing that advertisement, my machine now, IP-6AS dev lab 0, actually has prefixes from both my existing ULA prefix as well as the brand new one. So it's literally that easy, which is pretty cool. I'm going to remove that address because we don't need it. We demonstrated it now. And then now if we do this again, it's gone. And now those addresses will eventually expire. They will be considered not valid after a certain amount of time. I do so dislike the IP route tool set. It took me some getting used to. I think there are still parts of it I don't understand very well as far as things like multiple routing tables and IP rule. But I actually like the address and link functionality quite a lot. Once I eventually decided to give up ifconfig for good, I think my life has been better as a result. So for example, if I don't even want to see this. This is going to be disgusting, I'm sure. Yeah, see, I mean, I don't want individual addresses and then IPv4 subnet masks. Like this is gross. This is not how networks should work today. You know. Okay. Done playing around with the router. So we're going to advertise which prefixes we have, whether or not they're autonomous, and then maybe whether or not they're on link. What other flags do we expose? I'm surprised you even have ifconfig installed. Oh, can I remove it? Sudo apt remove ifconfig. I can't. Maybe it's something ifconfig plain doesn't support configuring to can't remember what. Yeah, probably some of the newer stuff, because I think ifconfig uses the old ioctl interface, and IP route 2 is all netlink, because essentially my understanding is it was the hello world for netlink and route netlink. So I should definitely try and get rid of these. I think the problem is I think I still do use netstat sometimes instead of SS. Net tools package. I guess that would be one way of forcing myself to get used to it, right? So sudo apt remove net tools. All right, goodbye. If config emp4 so. Beautiful. That is exactly what I want to see. So hang on a sec. Netstat nlp. Yep. Okay, perfect. No more. Rip off the band-aid. Love it. So this would be sudo ss-a grep 9430, something like that. Yeah, I'll have to figure out the SS ones. ARP not installed. Route not installed. That's okay. I don't use route either. I use IP-6RS. Perfect. Anyway. Thank you, Taryn, for the NetTools package hint. I would give you VIP, but you're already a mod, so. Yeah, don't support any tool that uses IPv4 or subnet masks in the 21st century. Just don't do it. A variety of tools. I don't use any of those. The one I actually used was netstat. That'll take a little bit of getting used to. I'll have to learn the SS equivalents, but that's okay. I know SS can do a lot more flexible things too, like AF VSOC and XDP and all kinds of crazy things. So when I'm troubleshooting my VSOC stuff, I remember using SS. Oh, no SS on Mac. That's super sad, actually. Adding multiple IPs to a single NIC with ifconfig is iffy. Yeah, right. I think that seems familiar. Wait, SS takes the same flags? No way. Sorry, Twitch stream. If anybody's not in chat right now, I'm getting pretty distracted by viewers helping me get rid of old bad commands. Let's see here. SS-NLP. This is what I would normally use. Awesome. That's core. That'll work. I'll have to figure out which one adds process names as well, but NTPL. Sure. Core. You can filter SS without grep. Yeah, I'm sure you can. I'm always lazy to remember to, you have it, you just need to run it as root. Oh, okay. Sweet. That is amazing, actually. So how about RTNL? There's a way to look at the netlink sockets too, right? So if I do -f netlink, right? Grep CoreRAD. T is TCP. Ah, right, okay. NPL-F netlink. Yeah, I feel like there was... Anyway, we should... I think we're probably... This is one of those things I'll have to figure out. But thank you for removing NetTools from my system. That's great. I'll have to make sure that's blacklisted from all my NixOS configs as well. So back to this. By the way, if there's anybody watching right now and you are not in the Twitch chat, I honestly highly recommend it. So one of the cool things about Twitch is being able to interact, being able to have a conversation, share tips, learn things. I drop links in there. So I would encourage you to check out the Twitch chat. This is not a totally crazy spam memes chat, so would recommend. I just ran out of water, actually, so I'm going to take a quick break and go to the bathroom as well. I'll be back in just a couple of minutes, so BRB. Okay, we are back. Shout out to Ashley McNamara. I unfortunately do not know her married name. I'm not sure if she still professionally goes by Ashley McNamara, but love this t-shirt. Go community. Super great. Yeah, so I just realized we've been streaming for a while, and I have that OBS Prometheus exporter thing running, so I kind of want to check out and see what it's doing. So I'm going to flip over to this really quick. I'm going to pull up Chrome and make sure nothing incriminating is on the screen. And then we will share with you all, and we can check out the metrics for my stream. So, Prometheus. Nope. OBS underscore. Oh, hey, nice. I got all kinds of stuff in here. OBS output bytes total. So irate over 5 minutes. Sweet. So you can actually see now. Here we go. So this is my local Prometheus. I have the OBS Prometheus exporter running as a compiled C shared mode Go plugin for OBS. And as you can see, we're actually picking up data from the stream and it's being imported into my Prometheus. So we can see like the current output rate for RTMP, which is Twitch. Twitch limits it to 800K. Is this in bytes? Yeah, it's in bytes. Okay. It seems like awfully high actually for bytes. I thought Twitch limited it to like 6,000K. This might be one of those like IEC versus metric things or something like that. And then the local stream outputting to my disk is substantially higher bitrate as well. So this is what's going to go to YouTube. So very cool. OBS lagged frames total. Am I lagging frames? Oh, just a few. Okay. So 13 lagged frames over the course of the past, what, hour and 45 minutes? That's pretty cool. You're sourcing at 1080p 60. I think I'm doing 1080p 30 actually. I feel like when I was looking at it, it was possibly struggling slightly at 1080p 60. I don't know. The thing is I'm using a nice CPU, but I can't use the GPU accelerated encoders. 1080p 28? Really? I just see 1080p on my stream. Hang on a second. Let me pull up the advanced video stats. 28. Wow, that is odd. As far as I can tell, I'm set for 30 locally. I guess I'll check my OBS settings after the stream, but as long as it's not bothering you all, I guess we might be 2 frames lower than we're supposed to be. Maybe? Huh. Maybe I need to drop the quality on the local stream just slightly or something. Yeah, time dilation, exactly. Cool. Anyway, so I will definitely make some dashboards for this. Let's see here. I'll make some dashboards for this, and we will have something public that we can share for stream stats, which would be pretty fun. So, cool. Back to where we were. I have a GitHub notification. What is it? Oh, that conversation. Okay. We'll check it out later. And we're back. Okay. So back to what we were doing. We now have one new metric with the prefix autonomous bit set. So I was trying to see if there's anything else we really care about, right? So if we do another router solicitation, things we care about, maybe the on-link flag, I guess could be useful, but I don't really care about that myself. The router lifetime could potentially be useful as well, because that would be switched to 0 in the event of a shutdown or an interface that stops forwarding packets. But we can also correlate that. We already have a metric for that too. So, the DNS servers will never change. Yeah, we can consider the DNS server stuff, but I think for now we'll just look at the prefix information again a little bit more and see if there's anything else we really care about. But so the only flags I expose, at least, are on-link, autonomous, and then we have the valid and preferred lifetimes. So we can expose the valid and preferred lifetimes as well, but we don't really need to. I think we'll just do on-link for now, too, because we can have a couple of Boolean pairs here. Prefix on-link. On-link. So in order to add that metric, we will go back here. We will copy and paste lots of things. Probably more efficient ways to move around. I know VS Code has all kinds of like keyboard shortcuts and the fancy multi-cursor stuff, but I do not know how to use a lot of those things. It's kind of funny how I use this every single day and still like there's lots of stuff I don't know, you know. Prefix on link. Whether or not the on link flag is enabled for a given prefix. Yes, right. Does not need to be registered because my interface does that for me. That's nice. Is that it? I think that's it. So now we can make a new development build, do it again. Probably gonna need the password entry again. Yep, let's do that. And then we have the, okay. So now if we curl this again, prefix underscore. There we go. We can see both these prefixes are being advertised as on link, which is true because they're in the same L2 reachability domain, and they are being advertised. Only one of them is autonomous because that is the configuration I specified in my config file. So that's great. Cool. Let's add a test for that. That seems like a good use of our time. And then we can probably wrap it with metrics for the day. Maybe not wrap the stream quite yet, but wrap it up with the metric stuff. I'm pretty happy with the way this came together. I think this metrics API is pretty good. I think that when I get into things like histograms and summaries, it will become somewhat more complicated. But that being said, since I didn't need a lot of the flexibility exposed by the Prometheus package, I think this is a pretty good trade-off, you know? And to be clear, I am using the Prometheus package internally. I'm just wrapping it. So yeah, this is probably going to need to be extracted to its own function eventually because this type switch is going to get pretty long if we start exposing metrics for everything. To do metrics for other options and base RA info. Is there anything the base router advertisement really care about? Hop limit, flags, preference. Preference, maybe? I don't know. Router lifetime. I feel like router lifetime would be the one because that indicates that how long your host or how long your router can be considered a default router by other IPv6 clients. That would be the one that comes to mind. Wow, Twitter's going wild over here. Cool. Okay. Anyway, I think that's probably fine for now. The one we're probably going to want to consider is default lifetime. Like default lifetime. Right. So now we have these metrics. They are being added. We need to write tests. Because how do you know it works if you don't test it? Right? So, probably... I guess this might be a case where we want to add possibly a new top-level test with a simple configuration. Ooh, excuse me. So test advertiser, unsolicited, unsolicited. These are all kind of a group of things. Solicited, verify arrays, multicast. Okay, here we go. We'll add it down here. So actually, I don't think we're going to need this code anymore. I think we'll know if we had these cases or not. So close. Oh, yeah, cool. And we'll bring back the little go watch thing over here. So first step is going to be test advertiser Prometheus metrics. So we're going to create a configuration that exposes kind of what we just did in the CLI or the config file. So we're going to have two prefixes that expose onlink and autonomous in different ways. So we don't have DNS SL. We don't care. We don't care about MTU. MTU could be interesting to expose too. Yeah, we can specify the link local address. I guess that's fine. 1020, 1020. Oh, this is a route. This isn't even a prefix. That'll get confusing. I could expose routes too. Anyway, so 2001 DB8, we'll do 1111. /64, we're going to pretend these subnets, so onlink and autonomous. Indeed. So this second subnet will have neither of those things. So expose two prefixes with differing flags to verify against too long the metrics output. We do not care about either of those fields. We don't really care about the link local address, like, right? I mean, we could just omit it, but it's not going to hurt anything either. I mean, I don't know. We'll get rid of it for now. So we read an advertisement, we halt the advertiser, and verify the metrics output, right? But the metrics output comes from this client context, so we don't expose it elsewhere. Yeah. Yeah. This is kind of one of the things I wanted to mess with a little bit more, is that these functions have a tendency to get pretty nested because we are doing test tables and then table-driven tests and then a subtest and then a closure. So suddenly we're 4 levels of indentation deep before we're writing any logic here, and we're going to write a lot of stuff inside this block, which is unfortunate. All this logic can go away. We don't actually need it. Oh, actually, I pulled it out of the closure, didn't I? Yeah, that's probably tidier, right? I mean, we can get rid of all of this. We don't need the defer done. We can just done right now, because whenever this runs and we get a router solicitation or router advertisement, it will capture it, it will type insert it, it will come out, and we're done. So, okay. Where is that series? Right, we're going to take this code again. So I think we're going to factor this out because we're going to need something like this in some form for a while. So, oh, it's literally right above where I'm working. That's convenient. Lots of test helpers in this code. This is the UDP stuff I was talking about earlier. So this implements that system-con interface using UDP by essentially reading like a UDP message that contains neighbor discovery bytes, parsing the message, and then returning it as if it were coming from a neighbor discovery connection. So that works surprisingly well. I'm happy with that. We will shoot. We've got a lot of helpers here. Shell, syscontrol. Okay. So func, what do we want? Filter series, right? We want to filter out time series by the name of a metric. So filter or find metric. Find metric, yeah. T, testing T. I really should start passing testing TB. I have a tendency to not do that. But the thing is I don't know if I have any benchmarks for this, honestly. Maybe I should, but a lot of the gains are to be made in places like the NDP package instead. So we have the name of the metric we're going to filter. We will return a TS samples. We'll return an individual time series, right? So one of these metrics series structures, I believe, is what we're going to do. So we pass in the name of the metric we want to find, and we pass in the metrics node. So I'd like to use the convention LL for a local logger, and then MM because it kind of parallels LL. It's kind of silly, but I think it works pretty well. And this will return, I believe, a metrics series, right? Is that what it is? Because we're taking it out of the map, and we're going to return a single entry from the map, which is this metrics series structure. Yes. Name, help, and the samples collected for it. Right. So we return a single metrics series pointer, and then a Boolean indicates whether or not we found it. Actually, I guess in this case, I could just assume that if you're calling find metric, you always want to find it. So I will return I will just crash the test. I'll do tfatal f if I don't find it. So, yep. This is no longer the client context. Metrics now does not support series output, right? So filter sname. So if name does not equal, if sname does not equal name, the series name does not equal the name I filtered in, we continue. Filter to only return the specified metric. Down here, T fatal F. No metric with name %Q was found. Name. And then I need a return statement, don't I? Panic unreachable. Right. So now this is different code. So we actually want to just return TS. Panic after fatal. Yeah, so the Go compiler will tell me I need to have some kind of return here, like either a return or a panic, basically indicating the function like does not return. But tfatalf is not flagged that way. So you need like a panic, or I would have to like return an empty metric series, which I guess I could do too, but I'd rather have a panic in case like if I change this like an error f or something, I would rather have like a panic here, I think. We should do t helper too. That will make things nicer. So we return ts. So this just filters out nsame, sname. Sname. Okay. So now we have this find metric helper. Oh, in case t is nil, it might not be a returner. Got it. In case t is nil. If t is nil, I think these would panic, but maybe not, right? I mean, I thought that the fatal F and stuff would panic if t was nil, but I guess I'm honestly not sure. Common fail now. Maybe this common thing can never be nil. I guess, I don't know. I don't actually know. I know the testing package does some strange things as far as like exiting Go routines, which is why stuff like this works. But I've never looked into it in depth. So now we want to go back to the other place we called series and use this helper. So what we want now is find metric t, the metrics node of the client context, and then RA inconsistencies. That's a hard word to spell. TS. We can remove all of this code, which is great. TS label. Cool. That seems pretty nice. Go test. So we actually want to do dash run equals, dash run, test advertiser, Prometheus metrics now is what we're going to want actually. So we'll take the same code, copy and paste it. So we're doing that outside the scope of the, I think in this particular test it needs to run within the scope of the client context because it has to be able to talk to the thing. But in this, we're just receiving information once and then verifying it. So we don't actually care. We can stop this immediately and then begin pulling apart parts of the array. Oh, we do need the metrics now, don't we? That's right. Well, I don't know. Actually, do we care about the router advertisement? I'm not sure we actually do. We just want to consume it, but we don't actually care. Do we want to verify the... I guess we would, actually. We want to verify that the prefixes that show up in the router advertisement are also showing up in the metrics. So we do care. Okay. Which is a metrics node. Actually, no, we don't care about the metrics. No, we want the time series out of it. So, right? So we care about the series. So map string metric series. Oops. So cctx dot. Oh, but then this helper only works on, right? Well, I guess I could pull out the individual series. Right? I mean, series equals find metric within the context of this, and then now we have the name of the metric itself, which we're going to factor out into a constant because it's just too easy to make typos with these big long names, you know. This is kind of what Prometheus mandates. Like, this is the style. It is awfully verbose, but realistically, you write it once and then never care about it again, so it's fine, you know. RA prefix autonomous. Oops. VS Code did the coding for me, and I just undid all of that nice work. And we're going to do the same thing with the onlink as well, but we'll do them one at a time just to verify the idea is solid. Although I don't see any reason why it wouldn't be. RA prefix autonomous. So this actually be PFX auto, something like that. Prefix autonomous. Gather only the necessary information after a single RA and immediately stop the advertiser to verify the output. Right. Verify the presence of matching metrics for any prefixes produced by the router advertisement. So, you know, this is... I guess we already have the prefixes up here, right? Like we could factor out these two into variables and then use them directly and totally ignore the array. But I feel like at the same time it might be useful for us to test the array output because that is what the clients would see. We want to verify that what the clients see matches. But the thing is, we probably have other tests that cover that too. So I feel like it's probably okay. I don't know. We can leave it alone. I've got a couple little helpers in here that make it easier to get options out anyway. So we want the, what is it? Pick prefixes, yeah. So out of a slice of NDP options, we can pick out all the prefixes from it. So, right, so for PFX within, or I guess we could just do P, we don't need PFX. For the prefix within the range of the router advertisement options, we are going to pick the prefixes only and iterate them. So given we have the more stuff we got to pull out of the closure. I guess we could just do this within the closure too, but I don't know. Face equals cctx router name. As I've mentioned, I'm not the happiest with these tests. I think that there's probably some improvements to be made. Ultimately, they do a lot of valuable work, which is great, but there is a fair amount of mental overhead, and some of these abstractions, like we're seeing here, can be a little awkward. Like it would be nice if this function returned the client context when it was done, but I don't really want to refactor that into every single test right now. So that would solve a fair amount of problems. So I think what we want now, I guess let's dump the time series really quick and just see what we see, because otherwise we don't actually know. Log print line iface, no, pfx auto, because we need to that's right, we need to underbar array and iface. So we're going to dump the time series that comes out of this and just verify what's in it, and then we can go ahead and start testing for it. Just to remember, get a refresher on what this actually looks like as output. So let's make this a little wider because this is going to be large, I'm sure. Right, so we have prefix autonomous, map test 0 prefix equals this. So this is the data we care about. Something in this format. So these are the kind of things we're going to assert on, because these are indicating that this prefix has autonomous address auto configuration enabled and this one does not, which is exactly what we'd expect. So we pick the prefixes out, and then based on the prefixes that are coming from the router advertisement, we can actually check the values of the time series and verify that they match up with what we'd expect. Is everybody following? I see chat's been quiet for a little bit. I know we're kind of getting into the weeds here a little bit, and I'm just kind of having to talk through my thought process, but if anybody has any questions, I'm always happy to answer. I mean, it's fun. It's fun to do this because you get an opportunity to share your thought process in real time, but also get feedback. So happy to take suggestions. Pick prefix. So for each prefix within here, we need to verify. I saw something move. Oh, I think it's my Twitch preview. Anyway, for each prefix information option, we need to verify P. So we want to take the bool float, right? So we're going to iterate over the samples in the time series because it will have two different series in there because we have interface equals test 0. So labels and value. Labels v. Range over pfx auto samples. Right? So given a label combination, test 0, prefix this. We expect value 1. So we need to check and see if the label contains the prefix. I'm also talking to the code. Speaking out ideas often makes a difference. Yeah, it totally does. That's actually one of the weird things about this. Like I find myself, when I'm coding by myself, I tend to talk out loud sometimes too. And doing it with Twitch chat feels surprisingly natural, like more natural than I thought it would. So if the prefix, none of my auto-completion is working at the moment. Is that because these are unused? Yeah. So if P contains, what is the value? I need to remember what's actually in the prefix information option. So let's see here. I'm doing it more often in home office, but avoid it in regular office. Yeah, totally. I work from home. I've been working from home for years now. So for me, it's like, this is totally what I'm used to. Pair programming where your partner is a bunch of people sitting at home in their underwear. Yeah, exactly. Remote life, right? Prefix. Yeah. So we can just look at the prefix, the IP in here, and then check the mask as well. But so if the two, we want to verify we find both. So I'm trying to think if we could like build just build a data structure and assert it based on, I'm wearing PJs, I'll have you know. I guess we could just build a data structure and assert on the sample map, right? Like instead of having to go through all this trouble, we could, this diff package will do the work for us. So we don't actually need to iterate the samples or anything. We can just compare. So for each prefix, we are going to generate a string that looks like this format. So we're going to have labels. It's going to be, and I feel pretty comfortable hard coding some of these presentation logic stuff because %s/%d, right? Yeah, because they're two different fields. I feel okay hard coding some of these things because we're going to be, we totally control this text format. Yeah. PIP, P prefix length, right? So this will give us a matching label now. So we would expect that this label would appear. And if it does not, then something is wrong. But if we build our own map, then we can diff against the other one, which will be really nice. So got is going to be a map of string to float64. I guess we could inline this. I mean, I guess it's actually a lot. Let's not. It's a little long. So got labels equals bool float of p autonomous address auto configuration, right? So what this should do is this should produce a map here that we can just diff against. So the map we want is pfx auto, and the map we got is our got. So unexpected prefix autonomous time series, right? Pick prefixes, right? Oh, I misspelled this. PIP. Yes, it does. Oh, it's called prefix, right? It's getting a little long. So new lines. I spelled this wrong. Back to the NDP package. I'm sure I spelled it wrong. Autonomous address auto configure. I didn't spell it wrong. I don't think I did. Okay. Maybe I did. Maybe there was a small typo in there I just couldn't see. So running all of this now, I would expect that we have now produced a map that looks roughly the same shape as the other one. Okay. See, that's useful. This is why I really like the diff package, because if we're able to see actually what we're expecting. Oh, right. So right now we're diffing the entire metric series, which has the name and the help associated, against just our samples, but our samples match. So the way we fix this is by pfx auto. Actually, I guess we could drop the dot samples. We could just go ahead and drop that. But We'll do it down here. It's more explicit, I guess. Samples. So the samples we want now equal the samples we got. And hey, our tests pass. Perfect. So I think this is pretty reasonable, right? Now we're verifying the autonomous state. Now we need to verify the other state. We need to verify the onlink state as well. So essentially it's just going to be a copy and paste. So pfx auto and pfx onlink. Now when you go back to the metrics file, we're going to close, verify, and option. We no longer need them. Prefix onlink is going to be factored out. So RA prefix onlink. Hey, Dominic, can you write a better spell checker so I don't have to run C-spell? It doesn't recognize things like RA. RA prefix onlink. But realistically, I would like that static nix first, please. That would be very useful for me. PFX onlink, right? So now we have the metric, and we are using that, so it's going to be produced. So now we can pull it out. So PFX onlink, RA prefix. Higher chance for static nix than a spell checker. Sweet. Okay. Well, I'm giving you that sweet GitHub sponsor money. So come on, chop, counting on you. PFX onlink. We're doing the same thing now. So we have got and can I make two maps at once? This doesn't work, does it? No. Var want got. That's sad. I was hoping I could just do like var, So instead of got, this is going to be called it's going to be called auto. I don't think there's any shorter way to do this on link. But if there was, that would be nice. So that's okay. Presence frame matching metrics. Right. So this is now auto. This is now auto. So this is now... The label sets are actually exactly the same, aren't they? That's convenient. Okay. So for auto and then for onlink. So since the labels are exactly the same, we can reuse those. P onlink. P onlink. Sheesh. Prefix onlink, to clarify. PFX onlink declared but not used. Oh, right. I need to actually do the assertion. Prefix onlink. And awesome. So with that, we now have tests that verify that given a prefix that is advertised, we produce appropriate metrics with the appropriate labels and the appropriate values. So I would say that's a pretty good test, I think in general, I'd still like to clean this up a little bit more as far as this test structure goes, but I'm not unhappy with the way this turned out. So let's see here. Prometheus metrics. Okay. Yep. More metrics. Commit to shell scripts. Yep, of course. Totally gonna do that tomorrow. No problem. But always like to look at the diff. I know doesn't VS Code have nicer diffing tools? There's stuff I could be doing in here, right? I mean, I just use the terminal stuff out of habit realistically, but I don't really want to use the... If I stage this at least, can I get a nicer diff? So if I stage all these changes, star go. Do I get a diff? Is this gonna do this? I've never tried this before. I apologize. Doesn't seem to. Stage changes, yeah. Oh, there it goes. Oh, that was okay. Cool. This is nicer. I mean, I don't think I'm going to use this all the time, but maybe if I'm doing a larger patch series. But I tend to be pretty strict about sticking to a smaller PR where at all possible. So, yep, okay. Hey, work on during a stream. We did it. Goal accomplished for the day. Yep. New test, all new code. Git doing git things with the algorithm. New metrics, new names. Quick editor flame war. Yeah, we've done that a couple times already. You know, VS Code's pretty good. As far as it's so weird because like I've been using Linux for like 10 years now, but I don't know. I tend to like a more out of the box experience because I find that if you spend a ton of time customizing your stuff, you can't use any of the other setups. Add the one true editor. Add is the standard text editor. Oh, small changes are nice, such as the one I've been working on for 3 weeks. 72 files changed, 3,768 insertions, 2,991 deletions. Yeah, so that's going to be the next version of Static Check, right? So hope you all are excited to run that on your code bases. I am. I run Static Check from master, so that'll be fun. Yeah, cool. I think we're in good shape to commit this. One more quick look back in my native editor, but oh yeah, proto files produce like ridiculous diffs for sure, but internal CoreRAD. These are new metrics for prefix information options. I firmly believe in customization for things like editors. If I have to work somewhere else, I need to clone my config. Yeah, I mean, honestly, that's probably the way I should work, right? I think the thing is that I haven't had good .file hygiene for a long time, but things like NixOS are changing that. So perhaps I will get better about it, right? If only I was brave enough to run it on my desktop. I don't know. I might have to try that at some point, right? And push. Cool. So I think that's probably enough metrics work for today. I don't want this to get too stale, right? So we're coming up in about 2 hours and 20 minutes in the stream. I'm still feeling good. We've got 15 viewers, which is about 14 more than I would expect. So thank you all for hanging out. I really do appreciate that. This has been a lot of fun. But let's see what else we can work on. Maybe some of the system stuff. I'm gonna lower the standing desk really quick. I'm getting kind of sore standing around. Uh-oh. I hope this isn't giving you guys like electrical noise. Let me see. One sec. Yeah, sorry about that. The motors on the desk run kind of close to like some of my AV cables, and I think I heard a little bit of static here, so I hope that didn't come through in the mic, but maybe it did. So I apologize if it did. Cool. All right, so back to what else do we want to work on? I think I'm probably at the point where I want to cut a new release pretty soon for sure. There's been a lot of churn, probably time for a new beta. So I would love if I could show you all how to take this and release it and get it on NixOS, but the problem is that it takes a while for the PRs to be merged usually, so I don't think that would happen within a single stream. Audio's perfect. Good. I'm glad to hear that. Yeah, I thought it might have been a little temporary thing. Yeah, I wish I could deploy this to my router the proper way. I wonder if there is a way I could do it. I know I could like build the derivation locally, but a 2-week stream, yeah. Yeah, I wish I could, I wish that maintainers were allowed to merge for their own packages, but I can understand the policies in place considering you could easily break or install malware potentially or do something to other people's systems. So that's, it is what it is, you know. But I guess before I cut a release, I'm trying to think if there's anything else I really wanted to do, right? I mean, let's grab for some of the to-dos in here. There might be some embarrassing to-dos. Find a way to reasonably test this. Yep, sounds about right. More verbose error reporting, decrementing lifetimes. Yeah, I definitely want to do that at some point. That's going to be a good thing. More events. That comment is probably out of date. Oh, nope. Yeah, so the network state watcher. This is a little package I created. I can show you all really quick. So I created this netstate package. Basically, the idea is it will abstract away things like route, netlink, and etc. into different different APIs and kind of merge them all into one. So you give it a channel, or you give it a list of changes, a bitmask you're interested in subscribing to, and it will put messages on that channel. It'll return you a channel and start putting messages on it. And if I go into the OS specific code, in the case of like Linux, this is using JC Manetti's RT Netlink library and my Netlink library as the base. So we're actually just listening for stuff on this multicast group. Excuse me. I think the problem with this is I suspect that there's probably no good abstraction for this sort of thing among multiple OSs. And route netlink, for example, can return multiple messages. So I've got this process messages thing that takes a set of messages, tears them apart, gives you the state changes. I feel like it almost might be worth not abstracting this per OS because I'm not sure if it really makes sense to do so. And also, it would be nice for me to have access to these raw messages. So maybe I do like the standard library, like what is it, like OS file sys, or no, OS stat sys. There's like a field that's an empty interface that you can type assert per platform. Maybe I need to do something like that and give you like the access to the RT Netlink messages. I'm not sure. So that is something that definitely needs to be thought about. But let's see here. Smarter backoff retry. Yep, of course. Unicast only mode. Use route netlink. Yeah, I need to replace the tests that are shelling out with stuff with route netlink calls as well. The problem is it's just a lot of boilerplate for something that is already pretty verbose. So I don't know. Oh, the HTTP stuff. Yeah, I totally forgot. We started working on that. That's something we could do. We were starting to write some code that would let us dump the router advertisement status for all the interfaces using like a JSON debugging API. I think that'd be pretty useful actually. So what I tend to do when I'm doing like a big overhaul and I want to keep something in Git is just store the files in a different directory. So I'm going to go ahead and cheat a little bit and copy some files back from text editor. Let's see. I think I need a new terminal. Pull that off screen so I can go do embarrassing things elsewhere. Temp HTTP. It's probably gonna pop up. Yeah, there we go. So like I'll sometimes like just save snippets like this elsewhere. This is gross, don't get me wrong, but if I don't want to deal with like Git stashing or branches, like if it's just really really rough, I'll deal with that, you know. So we'll bring that back in some form, and we'll also bring back, what was the other one? The data structures, right? We need the data structures we were building. So this will all be moved in a sec, but ra.go. So essentially what we had last time around is we were working on tearing apart the router advertisement and its options, unpacking it into a format that was more consumable with JSON. But then we ran into the issue where we needed to factor out the system state. And now that we've done that, this is actually totally unblocked. So I think it would be a good time to add a new method to the HTTP stuff. So let's see here. So here's a philosophical question. When I am making HTTP routes, I know there are strong opinions on how to differentiate versions. I personally feel like a header is the wrong way. That seems too non-obvious. Like, unless you're really inspecting the HTTP metadata, I feel like that's the wrong way. I personally have always kind of liked URLs, but I understand this is probably one of those very, contentious things. I started a workspace in code called Scratchpad where I autosave on and type paste random things. Sometimes I create name files, other times just Scratchpad. Yeah, I should probably have something like that. I think I have like an MD layer temp, but I tend to use that more for like quick Go programs because I need something with a Go module file. So for snippets, I have a temp directory in my home dir that has random other like tarballs and stuff. Oh, hey, Filippo just started streaming as well. Please don't leave me. I need my viewers. But we'll probably hop over there. Oh, we can send him a raid. Actually, that'd be fun. Using headers makes it easier to iterate and upgrade, downgrade responses like Stripe. Yeah, maybe you're right. Maybe. I feel like for now, I can just leave this unversioned probably. So no helpful advice other than try to avoid web stuff. Do you need that here? Probably not. Yeah, probably not. This is still kind of like a debug API, so we could just go with /API/interfaces for now. Yeah, oh, this is so exciting. So Filippo is streaming something. Yeah, I've never seen a raid on a programming stream before either. So we definitely need to do that. We are for sure going to do that. So I think we'll probably go for another half hour. In the meantime, if I may recommend, there are cool things like the multi-stream website. So if you're interested in doing some concurrent viewing, this is a pretty cool website I use a lot for my gaming streams. So, you know, I understand Filippo's going to be working on some very cool stuff. Yeah, two voices at once won't be confusing. Yeah, true. I'm sure Filippo's going to be working on some cool cryptography stuff if that's more your jam. You know, feel free. But that being said, we're definitely going to give him a host in a raid. So that'll be nice. That's so funny. I'm really excited actually. So H interfaces. Okay. Let's crank out this HTTP method and we can probably wrap the stream. I can tell I'm already getting a little bit hungry and I kind of like the 3 hour or so mark. So maybe another half an hour. And then I think that we'll probably call that good for today. I might do another stream tomorrow afternoon as well. I'm really enjoying this. I'll probably do one tomorrow, same time, most likely, 1 p.m. US Eastern time / I will post a link. Interfaces. This needs to be an HTTP handler, right? Response writer, our HTTP request. Wrong thing. Uh-oh. Did I get rid of that code? No. Shoot. Where is the scratch pad? Gotta go get it back. Filippo's done cool stuff with YubiKeys recently. Yeah, totally. So I use a YubiKey as well. So that is definitely interesting to me. He's writing a YubiKey agent, I believe, for SSH, which is awesome. I think that's a super cool idea. That's something I really want to set up at home. So I'd love to go help him out. Mux handle func. Get rid of this. Right. So the job of this handler is to build up the JSON body for a router that gives us router advertisement information per interface. H interfaces. Is this going to build now? No. So I need the configuration for each interface. iFace is a config, right? So I factored this out quite nicely, actually. iFace router advertisement. And we need to know if we are forwarding or not. So we can query the system state for doing that. See, this is pretty great because last weekend I was embarrassed by the state of my code base and some of the things I hadn't fixed. So I was motivated to fix them this week before the next stream so we could get back online and just like totally solve these problems. The thing is that like I'd love to solve some of this stuff on stream too, but the problem with that is you end up in a situation where I'm stuck sitting at my computer staring at it, trying to figure out the right abstractions and copying and pasting things. And it's just a mess. So I'd rather not make you all sit through that if I don't have to. H state forwarding for iFace name. Returns an error, right. We're going to need an error handler in here as well. This is just temporary. Cool. So with all the code, mux handle func, right? Yeah, because this isn't a type, it's just a function. Yep, okay. So by plugging this back in, this is code we wrote last time on stream, and we have these JSON data structures. Of course, you've got to do the JSON representation with all the tags. I'm debating whether I should do omit empty on some of these, but I can't decide if that would be too confusing or not. So I haven't done it yet. Anyway, so if we go back to the file over here, we're going to build this. We're going to run it again, and we're going to go ahead and curl it and see what still works. I'm going to make the text smaller briefly. I'm not sure how that's going to show up. Go away. Yeah, that's looking pretty small in Twitch stream, but this is just temporary. So we're going to curl localhost. And now we have this, is it debug interfaces or just interfaces? I can't remember. API interfaces, right. Into JQ. And there we go. We can see that we have two interfaces, CoreRAD v0, CoreRAD v1. One is advertising, and the advertisement it sends has the following parameters. So cool. I think that's a pretty good starting place for sure. So plumb in debugging API handlers. So interfaces returns a JSON representation of the advertising state of each interface each configured interface. Configured interface. Hey, thank you all for the Twitch follows, by the way. I have 62 followers, which I believe means that I am, as long as I keep streaming for like a few more days, I think I'm actually qualified for like a Twitch affiliate already, which is totally crazy. I mean, I think that means that I could like get bits or something, but I don't expect anybody to give me money for this. Like, I'm doing this purely because it's fun. It motivates me to work on my projects, and also, you know, a little bit of shameless self-promotion, right? But yeah, thank you all for your support. You know, this has been super fun. Definitely hope to keep doing it. Hope to keep, you know, growing the stream. I really enjoy, you know, getting to talk with you all, you know. You realize you have to have your own emotes. Yes, I think I get 2 emotes or something, so we'll have to, probably something Go related. Paul's allowing me to pan and match your 2 volumes. Oh, really? So you could have both Filippo and I up at once? Nice. Cool. Yeah, that's going to be so funny. I legitimately thought I would never do like a host and a raid either, but we're definitely going to do that. It's going to be amazing. For interfaces which are not advertising, only report basic information with a nil array output. Null in JSON terminology, right? Yeah, so we check the forwarding state. I definitely want to, we're going to need to plummet a logger too. We should do that now instead of getting lazy. I don't believe in globals. So Peter Borgen, I suspect some of you may have seen this, but let's see here. Go industrial programming, Peter Borgen. This blog and I believe a couple of the others are fantastic. These are really, really great reads. Let's see here. So I shared this in the chat as well. This is totally worth reading. Peter is amazing. Folks like, you know, Ben Johnson is amazing. There are tons and tons of great Go blogs out there, but I think that this blog in particular was really inspiring for me and kind of helped shape some of my philosophies. So it's great. I enjoy watching programming streams because it lets me watch others work. Started watching live coding streams with Brad and Andrew, HTTP2. Yeah, totally. I remember that too. I think I caught 1 or 2 of those. Live coding streams are really interesting. Like, I know it will never be the most, you know, like popular thing. And ultimately, I wonder how many people will ever like watch this after the fact, right? Like, you know, you all are here watching it live and I'm very grateful. But I'm curious if people are actually going to go and watch the whole YouTube video or, you know, parts of it or what. But this is a really unique environment, and it gives us a chance to just kind of share knowledge and teach each other. And I think that's really valuable, you know? So I'm super grateful for these opportunities. You know, programming streams are super fun. I've had a really good time doing it. We can make this larger. Oops. Nope, not preferences. Don't want that. We can make this larger again. And let's plumb this in a little bit more, get a test on it, and probably call it for the day in about 20-ish more minutes. First coding stream I ever watched was Notch re-implementing Doom and Dart. Really? Wow. So I've actually never used Dart. I understood it was kind of like I thought it was kind of like a front end like JavaScript alike. So it provides you access to like the OpenGL type stuff, or I think archive videos are great for specific exciting topics like HTTP2, hard to predict. Otherwise, live streams are better because of interaction. Yeah, totally. Like, I think that if I didn't have a Twitch chat here right now, it would be a lot less motivating, right? Yeah, this was years ago. That's cool. I'll have to check that out. Although I understand Notch is not the greatest person, unfortunately. At least that is my perception of him based on some of the things I've seen. That's unfortunate. You know, I wonder if, you know, I haven't heard from him in years. I don't know. But I thank him for Minecraft for sure. But I got into Go coding for 2 reasons. It annoyed my friend that I liked tab indents. It had written some horrible BGP code I wanted to replace. So I did. Yep. That sounds about right. 2014. Nice. What was I writing? I was going to write an error helper, wasn't I? Yeah, so meth h handler HTTP error, something like this. So now we need to plumb in a logger. Yeah, Go is a great language. I kind of learned it by accident, actually. I was doing PHP for a while, and a friend kept telling me to learn Go, try it. And eventually he convinced me, and we started writing a BitTorrent tracker. It's still on GitHub as mdlayergoat, Go awesome tracker. I'm not going to link you because I'm embarrassed, but if you want to see how far I've come, I think that's a pretty good benchmark, right? But Go is a phenomenal language. Like I like Rust a lot too. I think Rust is going to have a pretty strong place in my toolkit as well. I'm looking at the totally wrong file. I'm not even thinking. But I think that Go is, going to be one of my favorite languages for a very long time. Can't really imagine myself wanting to switch, He linked me yesterday. It was interesting. No. I hated interfaces, couldn't see the point. When they clicked, all of a sudden I became a much better Go programmer. Yeah, when you realize it's more about composition than inheritance. And don't get me wrong, when I'm building applications like this, I feel like I'm kind of sometimes leaning into the inheritance thing a little bit. Or the interfaces are maybe a little larger than they should be, but it still works pretty well. We need to pass in a logger here before I forget. Heard about Go from Jeremy Allison of Samba at Google, and later when I read about it more, I just love how practical it is and solves all the things I hated about Python. Goes the right direction. Yeah, totally. I agree with that. Avoided Go pre-Go 1 because I was in my Google is evil phase and my Ruby is great phase. Nice. Yeah, I don't mind Ruby. I think what's unfortunate is that most of my exposure to Ruby has been through Chef, and Chef has been a source of a lot of pain in my life. But as far as Ruby as a whole, I think it's a pretty useful language, There's plenty of Chef kicking around, yeah. Yeah, I can't seem to escape it. Right, I was gonna make an error handler because I don't like these. So, given some error, produce HTTP output for sure. So, let's see here, h.logger.printf HTTP server error %v error. And then we need to write to the HTTP response writer as well. Response writer. And since this is an internal API and I've already warned you not to expose it to the internet, I don't feel too bad doing error here. Right. So now we can HTTP error. Or I guess we could just H error, right? I mean, the HTTP part is kind of... We could H error F. That's even better. I love adding formatted versions of stuff. Error F. So this is going to take a format string and v ... interface for values. HTTP server error. So now I need to unpack this, right? Yeah, this is a format sprint f. Yeah, the format string and then the values, unpack them. And let's see here. We actually do need to format error f this, don't we? So error : equals format error f. Error f. And then error. Right? So now this is just the textual string of the error. Say hello to Matt Gray. Yeah, Matt is my teammate, actually. He's awesome. Yeah, I work with Matt on most days, and he's amazing. I've only met him a couple of times, but Twitch chat needs levels, like log levels, filter down to your desired level. Yeah, especially in big streams. Like, this is not bad at all, of course, but H error F. Let's see here, 2:41. Okay, so we got 20 minutes to finish this up. That's my goal. 20 minutes to get this working and get a bit of test coverage on it, and then we're going to raid Filippo, and it's going to be hilarious. Because I want to watch Filippo. I'm excited. Failed to check generate advertisements. Failed to check interface %q forwarding state. What am I? Oh, did I forget the W? Yeah, I did. My own stream is nice now, but I really want to watch this other stream. Yeah, I mean, I think that's a real problem though, right? Like, Filippo doesn't stream very often. I've been going for almost 3 hours, which is I found to be a pretty good benchmark for me. Like, I feel like if I go for like an 8-hour stream, you know, I'm gonna lose people real quick. Although, hey, we still got a good number of viewers. You know, 2 hours and 42 minutes in, so I'm pretty happy with that. But no, I think it'd be cool to support another fellow Go streamer. You know, I know, you know, Filippo definitely has a bigger audience than I do, but I think it would be cool to you know, show him some support, right? I've got a new video to watch after this. You've kept my attention. That's good to hear. Does this compile even? I have no idea, actually. Cool, it does. Yeah, so let's go to internal CR HTTP. We're going to write a test for this, and we're going to pretty much call that a stream, I think. I will most likely stream tomorrow, same time. I think that's probably my plan at the moment. I guess we don't have a log new nil. Or IOUtil discard, I guess, would be the proper way for now. Love some more Go on Twitch. Too much JS. Hey, yeah, for sure. I mean, I'm happy to hear you're enjoying it. You know, I'm here to provide all that Go content. I can never remember the parameters for this. You know, shoot. So log new takes, what is it? It's not going to compile. It's not going to work until it. Yeah. Oh, there we go. Output prefix flag. So don't care. Right. Okay. Test pass. So let's check the coverage. I don't think we have any of this tested at the moment. Time slot you had today would be ideal for me, but I just noticed the slate. Yeah, I will continue announcing on Twitter as well as the Gopher Slack. I'm primarily in the networking and performance channels, so I'll keep posting there until people tell me to stop. But I don't think there are too many people streaming Go for sure. But yeah, check out twitter.com/mdlayer. If you do !social in the chat, that gives you links to all my stuff. I'm going to try to advertise heavily because I want people to, I want to share content. You know, I want to do this. This is fun for me. So let's write a test for this really quick. But yeah, I like this time slot too. I think it's good because I can catch people who are, I'm East Coast US, well, I'm Michigan, but East Coast time zone. There are folks in here who are in California with 3 hours behind, and then we've got folks from Europe as well. So this is actually a pretty good time of day. Unfortunately, if I have an audience in like Southeast Asia, it makes things a little more difficult. Oh, Finland. Okay, yeah, so you're on a pretty big time difference from me. But yeah, I think this is a pretty ideal time for the folks that I generally interact with in the Go community, because this is the time I'm around and doing things as well. So, this takes no parameters yet, so we're just going to write a test that... This is kind of the little test framework we set up. So we build an HTTP test server. We initialize the handler with our input dependencies. We're going to need things like the system state for sure. We're going to have to swap that out. Let's see if we can get a test on this really quick. So interfaces. We're going to need to parameterize the input interfaces and the system state as well. But the system state can be a function? No. So we don't care about the logger. We are going to need state. So system.state. And we're also going to need a slice of config interfaces optionally as well. So TT state, TT ifaces, STT. Stateless tunneling transport, something like that. It's some really weird tunneling protocol that I've had to look into at one point. System state. I think I actually have like a mock state type in that package. I'm pretty sure I made one because I knew I was going to have to do this. Let's see here. It's not there. It might be in one of the tests. I might need to factor it out. Where test state. Yes, exactly. So this now should go into the exported API here. Type test state interface or struct. Test state is a state which is primarily useful in tests. Autoconf and forwarding. And perhaps you could do these more granularly, excuse me. have a hard time saying that word. I feel like my Midwest accent trips me up sometimes. There are certain things that are just difficult to say, you know. TSTS, autoconf, and forwarding. Autoconf implements state. As much as comments like this can be annoying to write, I'm much happier just satisfying GoLint than trying to fight it at every avenue. You know, it's just not worth it in my mind. Okay, so now the test state is gone, so we have system test state with a forwarding parameter of true, and those tests should now continue to pass. We can move back on over here. So, okay, this is now parameterized. We don't care about pprof in this. We're going to look at, we're going to have like two interfaces and then system state. So state would be system test state. And ideally, did I do it on the pointer? I guess that's fine. To do parameterize this per interface. But for now, we're going to say every interface is forwarding traffic. That's kind of not, well, actually, I guess we can make it shorter today by not. But we'll see how far we get. What I think I want to do is parameterize that so that each individual interface can be toggled on or off forwarding state so we can actually verify the true JSON output. I'm looking at the wrong file. But it's okay. You know, we can just do the basics for today. So we're going to check the forwarding state. We're going to generate a router advertisement, which will be packed into the body of the request. Okay. And then we JSON encode. So the path is going to be API interfaces. And let's just dump the body right now and just see what happens. So string body. This is going to be probably a JSON blob. Right. Go watch dash test dot or dash v. Yeah, dash v. Run equals test handler routes slash interfaces go. Hey, empty interfaces. Okay, sweet. So we have no interfaces. So no interfaces. We would expect a JSON object with no output. That is exactly what we expect. And we are testing this from outside the package. That's unfortunate. So we're going to end up probably exporting that type or making some kind of client, but for now we're going to cheat this. So to do export from the package. So we're going to use an anonymous structure here. This is one of my favorite patterns for handling JSON. So var v for value. Interfaces is going to be an array, a slice of structures. Let's see, what does an interface have really quick? We can just make it so that each interface has a name. An array of structs that have a name. JSON interfaces. We'll pull this out really quick because it's gonna go anyway. But type temp body struct. So the temporary body structure. We're going to unmarshal the JSON body into it. So var v temp body or body if error colon equals. Oh, is CoreRAD what I need to replace DNS mask with DHCP-v6 PD? Just joined here because I remember using some packages from you. No idea what you're working on. Yes, as Waffle says, it does replace RADVD. You still need a DHCP-v6 client, for example, in order to do prefix delegation with your ISP. But as far as a DHCP-v6 server, you probably don't need one at home. You could just run CoreRAD instead. So I'm probably going to tag a new release at some point later today. But right now, whatever's on GitHub should work just fine as well. Hit me up in the networking channel and Gopher Slack if you're interested. Also, the CoreRAD channel is a thing on Gopher Slack as well. So feel free to join us. But yes, it replaces RADVD, which is a daemon that works perfectly fine, but I wanted an opportunity to try something new and have things like Prometheus metrics in HTTP API and stuff like that. So we're going to unmarshal the body JSON into the, oops, this is going to be now a byte slice. I'm marshaling B into the pointer to a body. And now So we can log print f percent number v body. Sweet. So yeah, len 0. That's exactly what we'd expect. So you want 0, and you've got the len of body interfaces. Unexpected number of interfaces in HTTP body. Okay. So now we have a test case that passes with no interfaces. That's good. So we're going to add a test case as well, which will get interfaces that are not advertising, but for the time being, we're going to assume all of them are because it will make things easier without doing more refactoring. No interfaces, and then we can just call this interfaces, I guess. Yeah, that's fine. So we have the state, and now we need a set of configurations that will produce a router advertisement that we're going to unmarshal. So config interface. We will do the bare basics for today. So name equals eth0, advertise true. Oh, right. I don't need to parameterize it because that's controlled by the configuration. So sweet. I can actually do this right here. I can say that we have two interfaces, and one of them is not advertising. One interface in each advertising and non-advertising state. Yep, so now there's two interfaces in this body as expected. So now we have test coverage over all of this. Not the error cases yet, that's okay. We're gonna need to do a bit more work on the test state type. Yeah, I'd probably really want to kill DNS mask first. C, sends RA for IPv6 and used core DNS, core star, all the things. Yes, exactly. So core DNS and the core DHCP project, which is a Andrea Barberio from Facebook. I think it's his personal project, but core DHCP is something else. I have been intending to set up core DHCP, but I'm not running it yet. I am running core DNS, and yes, this was very much inspired by core DNS. So the name, but yes, core star, all the things. You know, let's write some Go networking daemons that get rid of more C on our networks, right? But yeah, DNS mask. Yeah, DNS mask would send RA, so you could turn that off and run CoreRAD though, and you could continue using it for DNS and DHCP. It wouldn't be too hard, actually. I don't know what the DNS mask configuration looks like, but I actually have an intro blog I can post in the channel really quick. One sec. mdlayer.com. This is my website. I post lots of stuff. If you're interested, blog. So this is an article I wrote called CoreRAD, a new IPv6 router advertisement daemon that kind of gives an intro to the project and what it does. Twitch kind of mangled that. RA names, DNS server. Yeah, you should be able to do all of that no problem with CoreRAD. It should be very similar, actually. And if you look at the default toml configuration that comes with it, it has every option outlined. And you can strip it down to exactly what you need. So, for example, if we're looking at an RA DVD config, this up here on the top, I'm pointing at the screen, but you can't see that. It's silly. The equivalent toml for RA or for CoreRAD is this. And then you can choose to enable like Prometheus metrics, and that's it. So I tried to pretty much use the same defaults as RA DVD because I figure that 95% of people are going to be coming from that. But I should make a DNS mask example as well. That'd be a good idea. But yeah, I would expect that you would be able to take this and run it today. So let me know how it goes. I've been running it at home for 4 months now, and it works great. So I would love more users. Please do join us. Okay, so we're just going to check the bare basics right now. So given, let's see here. The problem is with anonymous structs is, oh, I can actually iterate. Okay, so we would expect to see I guess we can just collect the interface names for now. Right? iFaces, interfaces, or no. Body interfaces. So names equals append, names. We're going to iterate over each interface in the body. IFI interface. Oh, that is the name. Right. Yep. And then we will compare that against a fixed list, which is going to be we're just doing this. We're just doing this kind of quick and dirty today because I just it's been about 3 hours. I think that's probably usually a good time to cut the stream. What's got unexpected interface names, and there we go. So we have started writing a new HTTP endpoint, the interfaces endpoint here, that will provide us a JSON output of all of our interfaces and their router advertisement state. So, yep, we're not touching any of this yet. We need to actually verify all these fields. We will do that in another stream. So we're coming up on like 2:58. So this is probably a good time to wrap up. Yeah. Oh, I see we have more viewers now, of course. Well, I guess that's good. We can send Filippo a nice 21 viewer raid. That's pretty cool. Don't see the configuration for DHCP-v6 prefix delegation generated addresses. So if you specify :/64, any addresses that are added to your interfaces will be picked up by CoreRAD. So that's exactly what I do. So if I log into my router really quick, IP-6 ASDev lab 0. This, oh, the lab is missing its, that's good. IoT. Uh-oh. I think Charter might have dropped my, that's fun. Okay, well, it looks like something weird is going on, I guess, with DHCP CD. So I've got DHCP CD set up so that we'll apply these to the interface. So this address right here comes from prefix delegation, and CoreRAD will take any address. If you do : /64 as the prefix, it will take any address with a /64 subnet mask and find all the unique subnets that are not linked local and serve them. So this is my primary LAN, and if I query for a router advertisement, you will see I get FD9E as well as 2600. So those are the two subnets being advertised using. This one is set up by prefix delegation, and this one is set up as a static address. So if you do : /64, it should just work. But prefix delegation. Something like this in the Debian wiki. Yeah, hit me up in the Gopher Slack channel. It'll be easier to troubleshoot there than Twitch for sure. Yeah, cool. Let's commit this really quick. Commit this and be done for the day. So just verify. Yep, temporary. Don't want to refactor a bunch of types right now. We have a test case where we have no interfaces being returned, as well as a test case with 2 interfaces, different states. Yeah, that all looks good to me. System as well as CoreRAD. We need to commit the shell scripts. Yes, that'll happen eventually. First pass at API interfaces, initial tests. Excuse me. And with that, we just crossed the 3-hour mark. Probably a good time to wrap things up, and we have pushed the last commit. So, yeah, thank you all for hanging out. This has been a lot of fun. We're going to send Filippo a host and raid, so that's pretty exciting. But in the meantime, if you're interested, check out the repo here. And I guess let's figure out this raid thing. Let's do it. But please do join me on Gopher Slack and other places, the networking channel, the CoreRAD channel. I'm happy to talk to you all. Yeah. Let's see how this goes really quick. Raid channel, Filippo. Oh, here we go. I'm so excited. All right. I will see you all later. Let's go raid Filippo. I've never done this before. I clicked raid. I have no idea what's going to happen. If I open this up in a different window, am I able to see this? Twitch.tv. I'm not sure if it worked. Anyway. Go check out Filippo. Let's go raid him. Should be fun. All right. I will see you all later.